I can't even unlock that.
All right. Okay. And then is there anything like specific if I might need to go grab?
Oh. So everything, I usually keep a box of extra stuff, but sometimes it gets used. This works for one.
Okay. So it's like a literal.
Yep. Okay.
I thought when Chrissy said shark, I thought it was like an act, like it stood for something else.
Oh.
I'm like, no.
Right. I know there's so many acronyms around here.
Literally talking about shark.
Nope, this time's for real.
All right. At least some things are straightforward around. Yeah, I just put an acronym on everything. That's funny.
What time is it?
3 till.
Oh, coffee. I gotta have my coffee.
Good call.
Oh, going for the comfy one.
Oh yeah, much better. I can get used to this over here. Over here, very recordings on my phone, so just not.
Which reminds me, I need to turn the voice sound off. Oh, it's that time.
It looks like he can see you. Can you hear us?
I can see you.
Okay.
I need to mute everyone. Let's make sure that everybody got in, and then we can start. Oops. Looks like we're still missing a few people. Great. So we're missing a couple people. It looks like they can get in a little bit late, and that's okay. So I'm Shannon Egley. I'm the anatomical coordinator here at JUMP, and I'm the clinical associate of anatomy over at the University of Illinois College of Medicine. What we do at JUMP is we do medical simulations. In the anatomy lab, which is this lab here, we do surgeries. So we do simulation for surgery so that surgeons get a lot of practice and they do their job really well when they actually see a real patient or work on you if you ever need to have a surgery. We want to make sure that they're the best and they've had a lot of practice doing it. At the university, I teach anatomy, so I get to work with the doctors before they're doctors, and I help teach them anatomy as they're med students. Then when they come over here, we work with them to help them get better at surgery. So it's kind of a cool thing. My background, I'm a biomedical neuroscientist. I like the brain, spinal cord. There's actually which shoulder we're looking at, this one, brain right there in the jar, and a bunch of models of brains all over the place. So if you get a chance to come to JUMP and work in the lab, then you'll get a chance to see that. You'll get a chance to see the lab, and hopefully we'll be open sometime soon where we can have our stems back here. But until then, it's cool actually getting to see a lot of your backyards or your kitchens or garages while we get to do these dissections. So it's exciting that we get to do this. You should have a kit, and the kit look like this. And it has a shark that came with it. When you go into the kit, there's two things you want to pull out right away. First is the manual, and second is the black bag. The black bag, we'll just save a little bit of time by setting it up right away. It's tablecloth. So when you open it, and I have my gloves on already, it's just a habit when I come into the lab. You're going to look for a seam. So one end, I don't know if you can see this, that's kind of a seam. So if you were putting this in the garbage can, this is the side that would be down, that doesn't open up. That's the side you want to grab a hold of. Pop it open. Now you have about a 4 foot by 5 foot tablecloth. And you'll take that and put it down over your table. So everything that you do will be right in the middle of this. Wherever your workspace is, make sure the center of the bag is in that workspace. I'm actually rearranging mine right now while you're doing yours. Great. I like to just make sure that it's far enough away from me that if I see a leak, I can push the leak back so it's not going to drip all over the place. So a lot of today, you'll actually be looking down right below where my camera is here is where we'll be doing the dissection. And I have my black placemat set out, tablecloth. Second, you want the book. And the book's really nice. It was kind of cool because I just wrote a bunch of words, and then Nicole in our media department actually put this awesome book together. So thanks to her. So we're going to go one page at a time through the book, and I'm going to flip cameras so that you can look at the book with me. Actually, before I flip cameras, or you can flip cameras, or whatever you need to do, but down on the bottom, right down here somewhere, should have a chat button. Go ahead and turn the chat on so that if you do have a question, you're all muted. You can have a parent type it in since your hands will be gross, but until then, if you have a question, you can type it in, and I'll keep looking over at the chat to see if there's a fresh question we can answer. So turn the chat on. I'm going to flip my camera. There it is. Perfect. And I just put a placemat on top of my bag, but you can see just a black bag. Right where my workspace is, I put the placemat. And it's a nice little promotion for OSF, Jump, and the University of Illinois. And also for PNC, because they give us a lot of financial support so that we could get these kits out to you and keep them really cheap. So it's nice to be able to do these things at home, and PNC helped us a lot with doing that. So first page, think like a scientist. This is one of my favorite things. I didn't actually go to college. I went all through grade school and high school, got my degree, and then I did a lot of jobs and didn't go to college until I was 30 years old, which I don't know if that was a mistake or was the right thing to do, but I never thought I would be a scientist. It just seems like a weird thing when I was growing up. But what I realized looking back is that we're always scientists. If you think about babies when they're first born, they're like the best scientists in the world because they're super curious. And that's what science is about, is being curious about what's around you and exploring and discovering and testing things. So when I watch my own kids when they're learning as babies, if you give them something like a ball, you give them a yellow ball, and what do they want to do with it? They want to put it to their mouth, right? So they hold it with their hands, they look at it, they check it out, but then they bring it up to their mouth. And the reason they do that isn't because they want to taste everything, it's because they want to feel it better. So the two most sensitive parts of your body are actually your fingertips, which is why I'm pulling my gloves tight, because I like to be able to feel creases and everything with my fingertips, and also with your lips, your face. That's why if a blind person reads Braille, they use their fingertips to read across it. But those two parts are so sensitive that these babies are exploring their world and experimenting and testing things. And they take that yellow ball and they put it up to their mouth. And then every parent likes to do this. Later, they give the baby a lemon that looks like a yellow ball. And then they put that to their mouth and they watch them pucker and grimace. And it's kind of fun. Some babies like it. And some babies are like, whoops, I'm never going to put a yellow ball in front of my face or up to my mouth again. But that's being a scientist. So they observe, they look at the yellow ball, they test the yellow ball, they feel the little yellow ball. They kind of question, they probably don't ask real words, but they wonder, what's it going to feel like on my lips? So they touch their lips. They get an experience with a lemon, and then they modify or change what they think about this thing, and then they treat it differently for the rest of their life. And in fact, if you see a lemon, you might start drooling a little bit, and your mouth might water if you think about eating it. So all through this, I really want you to think like a scientist. Be inquisitive, ask questions. If you have some question I don't answer, feel free to type it in the chat. I'll hopefully be able to answer it, or I'll try and redirect you to a place that you can find answers. So not everybody has the answers, but the important thing is actually knowing how to find the right ones. So when doing anatomy, my background is actually neurophysiology. So anatomy is something we have to do to learn the parts. Physiology is what we do to find out how things work. So I always thought, well, geez, the scientific method, how does that apply to anatomy? But hopefully you'll learn through this. One thing you can observe is you've all seen fish, right? A shark is a fish. I know it's a shark, it's a type of fish, but it's still a fish. So you've seen how fish behave. You've seen how fish react if you tap on the glass of an aquarium, or you know that fish have to breathe, right? So you've seen these things, but how do they breathe? Maybe that's one of your questions. They don't breathe like we do. I mean, we breathe in air that extracts oxygen, where fish have to get oxygen through the water. So do they have lungs? Do they not have lungs? Maybe that's your question. Maybe your hypothesis, or what your educated guess is. So if you thought, well, maybe they don't have lungs, so maybe they have to have another organ that replaces lungs. So your hypothesis might be that fish or sharks have to have a different organ to breathe oxygen. So what you do an experiment. You dissect a part of shark, you look at all the parts going all the way down to where they get oxygen, You collect that information, you analyze it, you put it in your notebook, which you can write all you want in this. You have a pen to do that. And then you reflect on it and you say, well, it looks like this organ must be it. And that's really how original scientists did everything, is they observed nature. When we first started learning about the brain, we couldn't just open somebody's brain, hundreds of years ago and check it out because they would die. So what would happen is we would watch people that had brain injuries. They did something stupid, like they crashed their horse and buggy or whatever, and they smacked their head really hard. We'd see where the bruise was. We'd see how they acted differently. And then we would decide that part of the head or that part of the brain that was underneath the skull there must be responsible for that behavior. It's the same thing with this. If you take the shark apart and you follow the pathway where air would go in or oxygen would go in, then you can find that organ, right? Modify it and repeat. Then maybe you watch or observe a live fish and see how they move through the water and how they move that organ you're looking at. So be inquisitive. Maybe you're wondering about the GI tract of a fish. I mean, do fish poo like us? We'll actually talk about that a little bit. How about fish when they have babies, or sharks when they have babies? We don't call them babies, we call them pups. But how do they do that? Do they lay eggs? Do they have pups like a dog does? So ask yourself lots of questions. If you come up with a question, like I said, type it in the chat or write in your notebook and we'll try and get to it later. All right, next page, have the right tools. So we supply you with a kit with everything you possibly need to do the dissection. But really, to me, the right tool is between your ears. So it's your brain. If you're not thinking correctly, you're not thinking the way that you should be thinking, you might get bored, you might not come up with cool ideas, you might not want to keep exploring past this. But if you approach this with the right frame of mind, you think, man, this is gonna be cool, I really wanna know about these different things, it makes it so much more interesting, it makes it fun. And then hopefully you keep exploring after this. So now that you know that a shark is a fish, and you had questions, but your shark's already in the trash and gone to the dumpster or whatever, how could you possibly keep experimenting? Well, I eat fish for dinner sometimes, so maybe you could talk your parents into buying a whole fish and helping them cut it apart, because now you'll know the parts. And you can see, is this fish that you're cutting apart different than the shark? Which, by the way, if you do cut a regular fish that we call bony fish apart, it has something called a swim bladder in it that holds air inside, and a shark doesn't have that. So maybe you could find that. But keep exploring, use your brain, be inquisitive. Throughout this, we're going to compare how humans do things to how sharks or fish do it. But maybe you could think, well, if a shark does it this way, how about compared to a dog, or how about compared to an insect or something else? Keep being creative with your imagination. All right, basic safety. So here are the tools you need to be safe. They're all in the kit. So if you want to dump your kit out, you can dump it right on the mat. Mine's over to the side. But let's make sure you have everything. First things, gloves. You should have 2 of them. And the gloves, I like to find smaller gloves. Yours might be just the right fit, but when you put them on, make sure your fingers are nice and tight. So throughout the experiment, I want you to use as many sensations as you can. So listen to things when we talk about the skin, feeling the skin in one direction and feeling it back. You can actually hear a sound when you rub the skin in one direction. So you keep putting your gloves on. How about smell? Yeah, when we open the bag, you're gonna smell some things. It's mostly fishy smell. You'll smell some chemical preservative smell too, but it kind of smells like an old fish. So hopefully you're doing this outside or in your garage so that your kitchen doesn't smell like fish while you're doing it. Sight, look at everything. Touch everything. So lots of things. The only sensation I would say avoid would be taste. You don't want to put anything in your mouth, please. It's funny, when I get the fish, they actually have in big bold writing, do not eat this. I'm thinking I would never want to eat this. Okay, so hopefully you have your gloves on. Next, eye protection. You have a set of goggles, just like this, and they're disposable goggles. I actually have my in-house goggles that I wear. I just changed the shield out. Which, by the way, hey Taylor, can you grab me a shield for my goggles? Thank you. Taylor is my sidekick today, in case I forget something. Yep, right there, eye level. It's just the shield. Yep, perfect. So the reason we wear goggles is because, well, hopefully you won't be splashing around. Thank you. Hopefully you won't be splashing around, but just in case you do get a little splashy, it doesn't go into your eye. So when you wear the goggles, you want to keep them tight to your face. You don't want to be like cool and have them down towards the tip of your nose. You want to bring it as close as you can to your cheek. So if something splashes from below you and goes up, it doesn't go under the goggles. If you have glasses, so some days I actually wear my glasses like I'm supposed to, and if my mom's watching this, sorry mom for not wearing my glasses, but my glasses actually come almost down to my cheek and touch, so that if I do splash something, my regular glasses will catch them. So eye protection. Next, an apron, just like this. When you open it up, it has 4 straps. It has these 2 straps that are kind of in the middle to go around your waist, and it has the straps around the head. Well, I guess looks like this one's already just one strap, so it's a loophole. Goes over your head and then tie your waist. You're wearing the apron so that if you do splash some of the fishiness towards you, you can just peel the apron off at the end of this and throw it away, and it doesn't stain your clothes or do anything stinky to your clothes. All right, so gloves, eye protection, apron. I'm wearing a lab coat, so I don't need the apron. Nearby sink is really important. So whether you're in a garage, hopefully you have a bathroom just inside the door, or you have a like garden hose outside that's on and ready to use. But you want to have a sink nearby so that if you do splash something, you can just take your face and run the water over just like this, tilt your head underneath and let it flow. And they say let it flow for 5 to 10 minutes, but a couple minutes until you're comfortable is usually best. The chemicals that are in it, we used to use formaldehyde in the old days. Back when I was a kid, we used formaldehyde to preserve everything. And actually, we still do use formaldehyde to preserve pretty much everything. Like, if you've ever wondered, and here's me being the scientist again, if you've ever wondered how it is that you can go outside, walk around in the woods, you get all that nasty mold and bacteria and fungus on your shoes, you walk in, you put them on the carpet, and then you take them and it just leaves the carpet dirty, but it doesn't mold. It's weird. So I actually looked it up, and it was interesting because I found out that carpet is full of formaldehyde, and formaldehyde keeps fungus and bacteria and other things from growing. The covers on your couch, if it's a fabric, formaldehyde. A lot of leathers are preserved in formaldehyde. Your kitchen table, the chemicals that seal it, formaldehyde. The seat that you sit on has formaldehyde in it. Almost everything around us has formaldehyde, and that's the preservative we use. Well, actually, we use formalin, which is a modified version of formaldehyde, so it's not very toxic. But it's preservative. It keeps all of those growth from well, ruining whatever you're wanting to keep. And that's why we use it on the fish, is because it keeps it from decaying fast. So technically, this thing could sit on your shelf for 2 years and still be fine. It's crazy, at room temperature. So nearby sink so that you can rinse off anything that splashes on you. Sharp and specimen safe disposable. When I use sharps, one of my just safety rules, or I always have to know where my sharps are. So I know how many of everything I have, and I know where they're at. And the person that packed this, oops, wasn't me. So I'll just rearrange that. But I have 6 pens. You should have 6 pens. Here's your mat. Yours might be green, purple, orange, yellow, whatever color. But you should have 6 pens across the top. If you have 5 pens, that's okay. If you have 7 pens, that's okay too. You just need to remember how many pens you have so you always keep track of them, and I'll remind you of that over and over and over again. Your second sharp, scissors. You might not think of them as being sharp, and your tips actually may be a little more rounded than mine. I like the rounded ones, but these are old ones that I'm using. I've used a bunch of times already. The rounded tips, we're not treating you like a kindergartner. The rounded tips are great for doing a surgical like dissection, because then you don't destroy things that you don't want to destroy. You can be more careful with them. But the blades are still sharp, even though they're meant for children. So you can either slide it underneath your pad, or you stick it into the pad. I just like sticking it into the pad. So I'll open it up sometimes a little bit just so it cuts, and stick it in. And then the last sharp thing you have, you also might not think of as sharp, but it's your probe. Your probe is also a little bit better than mine. Yours is shorter, but it's thicker. Mine's a little too wobbly. And yours is a little bit sharper point than mine does. So with my probe, when I'm not using it, I keep it in the pad too. So my sharps, I always know where they're at. They're always above me, so I'm not likely to go out and cut myself. But I have 6 pens, 1 scissors, and 1 probe. Those are my sharps. And now when I move this out of the way, I'll go with it safely. All right, so safety. At the very end, when we wrap everything up, I want to make sure that you put all of your sharp tools like this, whether they're jabbed into the top or whatever, so that the sharp part's always protected. I work with doctors a lot, and my biggest peeve when I work with a doctor is one that's distracted mentally and just sits a sharp down, like a scalpel or a needle or something, like a syringe with a needle on the tip of it, just sits it down and then forgets about it, and then they cover something. Nobody thinks about it, and then someone could grab that and actually cut themselves. So sharps are always really important to pay attention to, because you don't want to get, well, infected with whatever you're cutting into, for one thing. But you also don't want to get that cut. Right. Next, kit materials. We kind of walked through almost all of these already, but dissection manual right in front of you. The baby dogfish shark, not so much a baby anymore. So when we first started this, we thought, oh, cool, baby sharks. Everybody's going to love that. And then when we got the baby sharks, we realized that baby shark is actually no bigger than this page. So as far as width, and when you dissect into it, it's kind of hard to dissect. You got a cool jump pin, but I'm going to cross out baby right now. So you still have dogfish shark, and the word fish is there. So remember, this is a fish. So it's a lot like other fish, but we'll compare how this is different than most of the fish you eat. Your PPE, personal protective equipment, we just walked through. So your gloves, your goggles, your apron. You should have no dissection tray. It's actually a dissection pad, this thing. So it's easy to stick the pins into. Dissection tools will be the tweezers that look like this. You have a ruler that looks like this. You have the scissors that we just talked about, the probe, and then the pins. So you should have all of this, and hopefully you actually opened up your bag before we did this so you knew. And then table cover, which is also your disposal bag. So you should have everything that's in there now all accounted for, which means we can start the dissection process. By the way, everything in here is disposable. So at the very end, you can just throw it all in the trash, and I'll show you how to do that all in this nice handy dandy bag. If you want to keep it and your parents are okay with it, you can send it through the dishwasher. I just wouldn't wash anything else with it at the time that you do that, just in case, because it's kind of oily and gross. If you do other dissections with us, we still provide all the pieces. So I'm going to pop my safety goggles on. All right, shark autopsy. So when we do autopsies, quote unquote, in STEM, we do things with like pigs or sheep organs or sharks. And I always remind people that auto means self, and then opsy is to look at something. So you're looking at yourself basically when you're doing an autopsy, which seems weird because, I mean, you're not cutting yourself open. But the doctors that do autopsies are humans that cut apart other humans to find out what the cause of death was, or what they could have died of, you know, whether it's natural or for a wrongful reason. But autopsy is not the perfect term for this. So necropsy, the word down here, is actually the ideal word, because a human dissecting a human is an autopsy, but a human dissecting any other animal is actually a necropsy. So who would do necropsies? If a medical doctor does an autopsy, who would do a necropsy on other animals? Think about it. Well, what kind of doctor works on animals? A veterinarian. So veterinarians actually do necropsies. And I used to think, why would they have to do a necropsy? When my dog passes away, I'm pretty sure it'll be because of old age. I kind of know they're not going to have to dissect my dog to find out what the cause of death was. But then I started thinking more, and a couple of weeks ago I had raccoons in my basement, and I thought, well, what if something happened to the raccoons and it wiped out a bunch of raccoons? And so let's say a forest ranger was driving through the woods and sees a dead raccoon on the side of the road, but it doesn't have tire tracks. So they still pick it up and they take it back to dispose of it. But then he's driving like 10 miles down the road and sees another one and another one and another one. None of them have tire tracks. How do you know what killed them? Necropsy. Should they be concerned about all these raccoons dying? Maybe you don't like raccoons and you say nope, but raccoons actually have a really important place in our ecosystem. They do things for us, so we need raccoons around. So they would take these raccoons to a veterinarian. The veterinarian would do all these individual necropsies on these raccoons to find out what the cause of death was. So maybe it was because they ate something they shouldn't have, or maybe it was a virus, which is significant to the time that we're living in right now with the pandemic. So maybe there's some raccoon virus that was contagious and killing all these raccoons. We need to find out what it was to find a way to stop it, because we need raccoons around. So what we're going to do is we're going to do a necropsy. We probably won't see the cause of death on the sharks, but we're going to go through and we're going to look at all the organs. We're going to compare the organs and find out what your shark's like compared to everyone else. So let's meet your fish. So, dogfish shark. First, it's primitive. When I say primitive, I don't mean like it's old and dumb like a caveman. I mean primitive is, and sharks have been around a long time. I was actually, haven't fact checked this yet, but I was talking to an engineer the other day and he said, you know, sharks have actually been around longer than trees. I thought, what? No way. But then the more I thought about it, I thought, well, actually, that is possible. So sharks have been around a long time. In fact, if you looked at the pre-lab stuff, which was kind of for fun, you didn't have to do, but it was cool. If you looked at the goblin shark shark has the oldest ancestry because its ancestors, it's still alive, but its ancestors have been around for over 125 million years. So it's crazy, very primitive. They're vertebrates, so they're a lot like humans in the fact that they have a vertebra and a spinal cord and a brain. But when we look at them, they're called chondrocytes. Now I'm looking at it. Chondrichthyes. Chondra means cartilage. I'm just writing cart. Ichthyes is referring to fish. So the fish groups. So it's saying this is a cartilage fish, which is a cartilaginous fish. It has no bones. The shark skeleton is actually all cartilage all the way through. The hardest substance in its body are its teeth and its scales. Just like us, our hardest substance is teeth, but our teeth are actually not bones. So it's one of those little actually things. And that's one of my favorite things about science is that when I learn more, when someone says something that I contribute to, I say, actually. So when people talk about, you know, our hardest bone is our tooth, I can say, actually, the tooth is the hardest, but it's not a bone. And then I lose a friend. I'm kidding. It's some of the fun things that you learn about. Like if you learn about viruses and you can talk to people about COVID-19 or whatever, it's fun to learn those pieces of information, right? There are over 1,000 species of cartilage fish, and there are only about 400 that are sharks. So there are other fish that don't have bony skeletons, like a lamprey. They actually don't even have a jaw, so they're a little more primitive than a shark is. A shark was one of the first creatures to have a jaw, a working jaw, which is interesting. This is one of my favorite facts about a shark is that so usually they're ectothermic. So most of them are ectothermic, which means that they get their body temperature from the surroundings. So if they're swimming in a nice tropical water, they're the same temperature as the water. But if they go into an Arctic water, they're colder blooded. And you don't see a lot of sharks in Arctic water because if it's an ectothermic shark and it goes in cold water, it doesn't move very fast, which makes it a really bad hunter. It's just like you in the wintertime. You just want to curl up in a ball, right? Even if you go outside and play and you're running for a little bit, you're like, oh, so cold. You go in and you curl up in a ball. You just want to sleep or roll up in a ball. But when you're warm and you're excited, you want to play and run and do things. Well, sharks are the same way. If they go into cold water, they don't want to swim very fast. They want to slow down, which means they can't get food and they'll most likely starve to death before they freeze to death. But some are endothermic. So this is kind of a cool thing about anatomy is that anatomy is kind of like kindergarten for scientists because it's learning a lot of new words. Endo means within. Thermic means temperature. So this shark, an endothermic shark, actually generates its own temperature from within, just like you do. So when you're cold, what's your body do? What do your muscles do? They start shaking, right? You shiver. And what happens is the muscles create friction. Like when you rub your hands together, down at a microscopic level, they do the same thing. They rub against each other. They warm up your blood, and they send that warm blood to the rest of your body. Some sharks can do that. Tuna fish can do that too. And we'll actually look when we cut into the shark, there's a special group of muscles that is made for warming the blood. It has more blood vessels than the other muscles, and it can use friction to warm it. So kind of the big picture, now you know a little bit about your patient victim. Some of the things to keep in mind is that they spend their whole life in water, but they have to do a lot of the same things that we do. Like they have to eat and they have to breathe, even though they don't breathe the same. Their structure, the way that they're designed, they have paired appendages, like you have 2 arms and 2 legs. So we'll kind of compare us to them all the way through. And if you want to look at a deeper scientific background, just look up taxonomy of shark and human, and it'll show you a lot of things that we have in common. So I'm a huge fan of Google. I don't trust everything I see on Google. I have to make sure it's from a good source, but I like to find fun little interesting things on Google all the time. Okay, external examination. Now we're opening the shark. So you're going to grab your shark, but before you open it, I'm going to walk you through mine. 1 second. So, shark, whoops. You bet you want to see my shark. Let me show you. There we go. Like this. So just like yours. When you're opening the bag, the first thing you want to do is you want to cut on the end that has the head. So my shark had 2 sharks in the bag, and I cut the end open. But the side that has the seam and the head, pop my fish on the ground. You're going to cut right along the top, and then it'll open just like this. All of the juice is down at the bottom, so you want to be close to a sink when you cut this. So just listen closely, then go to the sink, or a garbage can is fine too, as long as it's not a leaky garbage can. You're gonna cut the top and you're gonna tilt it over and let all the juices drain into the trash or into the sink, and then let hot water run afterwards. When you're done, tilt it back up so the head's facing up and the hole's up. Then you walk back to the table, leaving the shark in the bag the whole time. And when you get to the table, then you pull the shark out. Pull the shark out when you're over the plastic, put it down. Take your bag with all the juice or any drippings that are left in there, because it's hard to get all the juice out, and set it straight up and down in a trash can that doesn't spill anywhere. Trash can right below me. The last thing I'm going to do is make your parents angry with this. So we want to keep this as mess-free as possible, and that's why we work on the bag. So at the very end, I'm not a huge fan of cleaning up a bunch of stuff. So at the very end, I can just push everything in the middle of the bag, and I'll show you how to take with one hand and wrap the whole bag and throw it in the trash. Easy peasy. Okay, so I'm going to let you go and open up your bag, drain it, bring the shark back, put it on the table, and then dispose of the bag. I feel like you need a little guitar and have intermission music or something. Do, do. You have one here? Oh, I always thought about bringing one. Yeah, I always thought about bringing one of mine and just sitting in the office, so that if I'm having one of those moments where I just need to forget about work and drift away. Yes, smooth jazz. Have you seen the new Troll movie?
Not yet.
Oh my gosh. The smooth jazz guy cracks me up. And yep, I am in my lab. Never asked that. So this is the anatomy lab here at Jump, and then we have an anatomy lab over at the university too. This one's made for surgeries. That one over there is made for dissecting to teach med students. And I'm just watching through to see how everybody's going. Handing off the bag to the parent, which, whoops, I forgot. Yeah, always make sure that you have a parent within ear shouting distance and sight. So even if they're 2 rooms away, make sure you can see them. So if they do go away and you cut your finger or you poke yourself or you make a spill, that you can yell for them. Still watching a couple people work. This is fun. Some of you I've seen in STEM classes here at Jump. So it's always good seeing people come back and do these things. It's a lot of fun. like most people are ready. How long is the shark? That's an awesome question, and we're actually going to find that out in about 5 minutes. So let me flip the camera back over. My shark on the table. Oops, I moved the chat box right over my camera setting. Let me get that out of the way. There we go. Okay, so before we actually cut into the shark, we need to use some proper terms. And this is a big thing about science and medicine, actually medicine even more particularly, because they have medical jargon. And the terms that they use describe what you're gonna do or where you're gonna to do things. So anytime a doctor sees a patient, everything that they write down in their chart uses medical terms, a specific jargon for them, that helps any other doctor or any other nurse or medical professional pick up the chart and know exactly what that person was saying. So we don't use words like a little bit to the left or a little bit to the right or above or below. They're actually specific terms and specific measurements that have to be used. So here in the picture of the human, you can see words like superior. So we don't say above something, we say it's superior to, because above depends on, is the person laying down? Are they standing up? How are they positioned? So the term superior always means towards the head, right? Inferior is the opposite. So if you have a boss, they're your superior and you are their inferior, which means you're below them and they're above you. So specific terms. If something is towards the middle of the body, we call it medial, not middle. If it's out towards the sides, like this, we call it lateral. So there's a more specific term sometimes used when you're talking about the arms and the legs or the fins, proximal and distal. So if we're talking about the fingers of the wrist, we would say, how is it compared to the rest of the body, right? So we would say that the wrist is proximal to the fingers, which means it's closer to the rest of the body than the fingers. Or we could say just the opposite. I think close proximity for proximal. If I say that the fingers are distal to the wrist, that means they're further away from the wrist from the body. So they're more distant or further away. Other terms. So these are more specific to animals, which is interesting because the one part of the body that we use these terms on is the brain. So dorsal and ventral. Dorsal means the back. When we're talking about a standing human, we call that the posterior. But dorsal means the back. Ventral means the front. Where you ventilate, where your nose is at, would be ventral, if you were a fish or a dog, right? And we use a lot of these terms not just for like describing on a chart, but also for naming things. So if you saw a fin on the back of a fish or the back of a dolphin or the back of a shark, you just call it a fin, but you call it the dorsal fin. It's telling you where it's at. Caudal, cranial and caudal. Caudal means tail, cranial means head, like your cranium is your skull. So cranial means head. So when we're talking about something that's closer to the head of a fish or a dog or a cat or whatever, we use the word cranial. If we're talking about something closer to its tail on a fish, a dog, cat, whatever has a tail, we call it caudal. So those are two other terms. If we're making a cut, we use the terms like superficial and deep. Superficial means close to the surface, which means you don't cut very far in. Deep means you go deep in. It sounds like what it means, but we can also describe structures like if you have a bone right in the center of your chest. So if you tap your chest, well, hopefully not with your gross gloves, you have an apron on. If you tap the center of your chest, right here, you have a bone. It's called your sternum. Some people call it the breastbone or the chest plate. It's the sternum. Right behind it, you have your heart that's peeking in there. So we would say that the heart is deep to the sternum, or the sternum is superficial, which means closer to the surface than the heart. And then the last thing is the way you're going to cut. So if I ask you to make any of these cuts, here's how you do it. A sagittal cut means you're cutting the thing in half like this and separating their left from their right side. So when we make a cut to go into the belly, we'll actually make a sagittal cut right along the belly of the shark so we can look at all the internal organs. Transverse means across, like this. Right? When we look at the heart and the shark, we'll actually make a transverse cut across so that we can open up the heart. Right? Frontal means you would cut the whole front off of something. So a frontal, we're not going to do it at all. but it's one of those general terms. So these three descriptive words tell you the three possible cuts. There's maybe a fourth called oblique, which means at an angle, but these are the typical ones that you'd hear over and over when people make cuts. They make a sagittal cut, a transverse cut, or a frontal cut. All right, let's look at your shark. Let's pop this guy up here. Shouldn't say guy because I don't know if it's a male or female yet. There's your shark. And let's see if we can identify some of these things. So first, pectoral fin. It goes back to the naming again. This is just like in humans. We call regions or parts of the body specific names, like we have a name for the pectoral region on a human. Think about it. You've heard this word, I'm sure you have. When someone goes to the gym and they work on their pecs, where are their pecs? Right? They're in the pectoral region. So someone that's lifting weights and they're like, yeah, man, I'm buff. Look at me. Right? That's the pectoral region. These are the muscles that they're working right across here. So the pectoral fins are the fins that are attached to that region. These. Right? I'm wiggling this like this, but one of the odd things about a shark is that even though it's a fish, it can't move its pectoral fins like most fish. Have you ever seen a goldfish in an aquarium that just stares back at you and its pectoral fin is going like this around in a circle? Number one, a goldfish can stop in the water. A shark has a hard time stopping in the water. Number two is that goldfish can kind of hover or move around with these because it can twist them. Sharks can't. Sharks can only move these fins slightly. So they're more like wings on an airplane than they are fins on a fish. So if you think of an airplane and the wings coming out, when a shark wants to turn, it uses these to go up and down just a little bit. But a shark can't come to a complete stop, number one. And number two, when it does have to steer, its fins do the steering. Right? And I'll show you more about that later. But that's another reason that we talk about wingspan on a shark is because they're like wings on a plane. Right? So the pectoral fins. Next, the pelvic fins. If you look at the shape of the shark, and we think about this as the pectoral region like on a person, and here are your arms, right? So the pelvic region would be the waist region. You'd keep looking down until you found the waist, right? And you can feel it. There's actually a cartilage, not a bone, but a cartilage-like structure, bone-like structure made of cartilage that goes across here just like your hips. And then here are the attachments, which would be like your hip joint where your legs attach. Right? These would be the pelvic fins because they're in the pelvic region. So we have dorsal, one here. Dorsal, there's one here. If you look at the dorsal fin, there's a little piece broken off here, and there's a piece broken off here. Because your shark is actually called a spiny dogfish shark, there was a needle-like spine here and here when the fishermen caught it. And then they had to cut that off for safety because there's a toxin, a poison that's in that. That's not poisonous to humans, but it can make your finger itch and scratch and cause pain if it poked you. So these are always cut off completely for you. Right? And we'll talk about that too later. Why would a shark want a spiny structure poking off its back? I mean, it's a killer, right? It's got mean teeth. Why does it have to have a pointy thing? So dorsal fin, pectoral fins, pelvic fins, right? Caudal fin, remember those two terms, cranial and caudal? What did caudal refer to? The head or the tail? Remember, cranial, cranium like a skull, caudal is the tail, way back here. And this is a tricky one because some books say that they have one caudal fin, but others say that they have two, because if you look, this lower one, the one that's on the ventral side is smaller, the one that's on the dorsal side is larger. So a lot of books that I've read say that all of the fins are paired, but then some other books I've read say that they have 7 because the tail is not technically paired. And if you look at the tail on different sharks, they're different shapes. Some are the same size on the top and the bottom. Some look like a whip, and it actually whips like that and strikes at its prey and shocks them. So sharks are pretty interesting. With over 400 different types, there are a lot of unique characteristics. Right? Lateral line. This is an important structure on a shark. See that stripe? It's not to make them look cool like a racing stripe. The lateral line is actually an organ that goes all the way along the body, all the way back to the tail, and then comes up the tail. And it's on both sides. It's a sensory organ that detects pressure. and it's called the lateral line. Why do they call it lateral? Remember the two terms? Medial means down the middle or close to the middle. Lateral means to the side. So the lateral line is as lateral as you can get on the body, as much to the side as possible. Right? Next are the gills. And you've probably seen gills, I'm sure. If you look at fish, there are things here on the side. So a shark actually has a soft covering on the gills. They're not very well protected. Where a bony fish, which are all the other fish that have bones, like a goldfish or a bluegill or a trout or a salmon or whatever, they actually have a bony structure that covers their gills and protects them. So if you watch that goldfish and it's hovering, its gill covering is actually kind of like flopping a little bit, because what it's doing is it's breathing. It's forcing water through and over the gills. And we'll talk about the gills a lot later. But for now, just how many gills do you have? See if yours are the same. There's 1, 2, 3, 4, 5. So 10. 5 on the side, 5 on the other. All sharks have at least 5 gills. There are some sharks out there with more. In fact, there's a shark that's called the 7-gilled shark. That's its real name. Guess how many gills it has? Right, 7. So it has 7 gills. And they just, sometimes science is boring. They're like, oh, we've named 400 other sharks. What are we going to name this one? They go, well, it has 7 gills. Sold. It's a 7-gilled shark. Right, so those are the gills. The spiracle is something unique. So here's the gill. There's the spiracle, that little hole right up there. And it's not an ear. I've heard people say, oh, that's the ear. No, it's not the ear. This has nothing to do with hearing. A spiracle is interesting because sharks, you may have heard this, sharks can't stop swimming unless, or else they'll die. Just kind of a truth to that. It depends on the shark. So if you look at a great white shark like Jaws, Jaws can't stop swimming or it will die. Great white sharks don't have a spiracle. So what they have to do is they swim, water goes into their mouth, goes over their gills so they can breathe. But if they stop swimming, water can't go in the mouth, can't go over the gills, and then they suffocate to death and die. A spiracle is kind of like, I don't want to use the word nose, but it's when you breathe through your nose, they suck water into the spiracle, they puff their cheeks out like they're sucking through a straw, and then they squeeze the cheeks hard and it blows the water over the gills. So they suck water in, puff the cheeks, blow it out the gills. So sharks that have spiracles, if they slow or barely move, you'll see them puffing their cheeks like crazy, like they're suffocating, because what they're doing is they're sucking water in and blowing it over the gills. So that's the spiracle, and we'll look at that too. We'll actually explore that later. The eye, you know where the eye is at. The eye, we'll talk about this a lot too. The eye of a shark is actually a lot more like an eye of a human than other fish. Nostril or nair, they don't have a nose, but they do have nostrils. So these little holes here, oops, something popped up on my screen. Let me fix that. Sorry. So they have these little nostrils, but they're closed or blind-ended. Now we use the term blind not because they see through their nose, but blind because they don't go anywhere. So it's actually a unique term for things that are a dead end. So blind-ended, where your nostrils actually go to the back of your nose, down your throat, and into your lungs. I took my glove off to fix my, just anything. Thank you. Whatever's closest. Thanks. So if you take your probe, which is right up here, and you kind of feel, it's like picking its nose, but remember this is in the nose. You can feel it doesn't go anywhere. It's actually blind-ended. And if you look in it and you have the proper light, you can see it's not going anywhere. It's just, that's it. So when a shark smells, it smells like you, but a little different. When you smell something, whatever the particle is, goes into your nose to the roof of the nose and sticks to it. And then you have receptors that send signals to your brain saying, this is what you're smelling. Then when you're done smelling it, it either, well, falls off and you can blow it into a Kleenex, or you swallow it. The only thing a shark can do is blow it back out. So a shark's sense of smell is incredible. If they had a drop of blood on one side of an Olympic swimming pool, they could smell it from the other side of the pool. It's crazy, crazy good. Right, cloaca. If you go down to the pelvic fins, remember they're down here. The cloaca is the opening in between it. So they're kind of like a chicken or a bird where they have one hole for urinating or pooing or having pups. That's all one hole, and it's called a cloaca. Okay. A rostrum is the nose-like structure. Remember, it's not a real nose, but the rostrum is the nose-like area, the pointy tip. So sometimes you'll hear people say it's rostral, meaning it's close to the nose. And the last is the mouth, and here's a good chance to actually look at the mouth. So the teeth, you can touch them. Kind of crazy when you open it and see how the teeth kind of project out. But you can look in. They don't have a tongue like we do. They have a structure that looks like a tongue, but it actually is different. We'll look at it in more detail later, but if you open it up and look, if you feel it, it's hard. It's actually just a slab of cartilage. It's not like ours. Our tongues have a lot of muscle in them. Right? Another thing you can look at are the teeth. So you can count the rows. Wow, for some reason, the camera's a little blurry today, but you can count yours and I'll count mine. You have one front row here. You have a row right over it. And then you have one right behind it if you can see back there. So there's a back row, a middle row, and a front row. I have 3 on the top. 1, 2, 3. Same 3 on the bottom. So when a shark loses a tooth, it doesn't have to go to the dentist, doesn't have to worry about cavities. It actually swallows its tooth, digests it for the calcium, and then the back tooth pops into the front. So they just slide. It's like rotating teeth. Wouldn't that be great? We wouldn't need dentists. You wouldn't have to worry about that drill sound. Ooh. Or that flushing spit, flush spit, flush spit. Annoying. Right. So those are our general structures. Now let's do some measurements. Let's compare your shark to the others. So let's find out how long this thing is. You need your ruler. And the ruler is inches on one side, centimeters/millimeters on the other. One thing to note is that 0 is not the end of the ruler. 0 is a little bit off. So here's a problem. First problem, this was great when we had the baby sharks, the little ones. But now we have these big ones, they're way longer than the ruler. So what could you do to figure out how long this is in centimeters? The first thing it wants is centimeters. Here's what I would do. Hopefully you're answering the question in your head before. Nope, not every shark has 5 rows of teeth. Some actually have a lot more. Some have less. Good question, though. So one of the other things I learned in science is that I never get to use the word always or never. There are always exceptions to the rule. Even in human. Not every human has the same muscles. If you didn't know that, look it up. There's actually one in your wrist when you do this that not everybody has. And you're looking at the tendon of it right there. Okay, so to measure this, I grab a stick pin. I'm looking at the tip of the nose, and I'm going to put that 0 right to the tip. Bink. Straighten out my ruler all the way back. I'm going along the dorsal fin, following, and then I'm going to stick this in at the 30 mark. Boop. When you push the pin in, the skin is kind of tough, so you just have to push until it pops. So now I have 30 centimeters. I'll grab another pin just in case I have a really big shark. I'm going to take the ruler and put it up to the 0 mark right there. Hold this flat along the back. Keep going, make sure it's straight. I can say he because I figured out mine as a male, and I'll show you how to figure that out in just a little bit. So straightening it out as best I can, straightening it out. And I'm going to stick this pin in. Whew, really long shark. At the 30. So now I have 2 pins. And the last thing I do is, I'm going to hold that up to the 0 one more time. Right there. I'm going to measure out to the tip, and I'm going to move this up and down just a little bit to make sure that I can see. Yeah. A little dark. There we go. So I have a dark dissection pad on a dark fishtail. Oh boy. I'm going to say 11 and a half. So 11.5 centimeters. So there are my lengths. 11.5 centimeters plus 30 equals 71.5 centimeters. That's the length of my fish. Uh-oh, someone has only organs? I think they gave you the wrong box. That is no good. If you, hey, Taylor, can you run down and ask what we can do if somebody has the wrong organs?
Just go ask.
Yeah, Christy or no. Yep. Thank you. Yep, everybody should have a shark. The organs are actually, they're big organs. You have a lung and a heart and a brain and an eyeball. That's a different kit. I'm sorry that that happened. I sent someone down to find out what we can do for you right now. So 3371.5 centimeters, but it also wants it in inches. You can do a couple things. You can either remeasure this using the inches side, which is fine. But I've got a friend. Hey, Echo. What's 71.5 divided by 2.54? .14, so 28.1 inches. So what I did is I took the 71.5 and divided it by 2.54 because for every inch, you have 2.54 centimeters. Boonk, boonk. Echo rules my house. All right. Echo, stop the music. I made a mistake. That's the only problem with it is when you say its name, it does whatever. So it was trying to play My House by Flo Rida. Thank you. Okay, next thing you want is the wingspan. So remember we talked about the pectoral fins being wings. You don't want to force them straight out. You want to hold them like they're airplane wings, right? So they kind of go at roughly 45 degrees. And then I'm going to put a pin here because I just took 2 pins out. Here, I'm just rearranging them and putting them back in, but I'm putting them into the wingspan. And the person that has just organs, I wonder what people are trying to get a hold of you right now, and we'll find something that will work for you. We'll either have this recorded or I can make a special arrangement to help you do it at another time. I'm sorry about that. So let's put this up to the tip. Remember, the 0 is not the end, so I put it about there. It's right next to the 0. And is at the furthest part. I'll hold this and kind of pivot it. Right there. So it looks like 21, and then each one of these little marks is a millimeter, so 21 centimeters. There's 5, 6, 7, and we'll go with 7. So my wingspan is 21.7 centimeters. Echo, what's 21.7 divided by 2.54? 8.5. So 8.5 inches. And when we do this in class, we usually take all the group averages and compare to find out with the averages to see where your shark falls. Is it average, is it above average or below? But just because of time's sake and complication, we're not doing that. But let's see, my wingspan is 8.5 and my length, sorry, 8.5 inches, and my length was 28.1 inches. So well over 2 feet. If you've got one that's over 30, let me know, because I think just below 30 is actually the record for these sharks. When we first started getting them, they were only supposed to be up to 18 inches, and then they were 19 inches, and they were in the 20s, and now they're almost getting close to 3 feet long. It's crazy. Right? I had 2 pins. I took my 2 pins out. I'm sticking them back in the top. 6 pins, scissors, and probe all my sharks. Cool. So we've learned a little bit of the terminology that we're going to use. We learned some of the structures that are based on the terminology. Let's talk about the systems. And the first system is the integumentary system. So integumentary system is a fancy way of saying the skin and all the organs that are part of the skin. So that's a tricky thing. When people just talk about skin being its own system, it's not. The skin itself is just one organ as a system. Your hair is another organ, because an organ are different types of tissues that work together. So skin has connective tissue and epithelial tissue, which are big fancy names for the different types of tissue that are in your body, but they're different tissues. Each of those tissues are made up of different types of cells. So connective tissue might have cells that make fibers to hold your skin together. They might have cells that make a jelly-like material that lets your skin wiggle on top. There are lots of different cells that make up this tissue. So when you get to learn more about the body, you learn how complex it is. Your skin is made of, your integumentary system is made of your skin, your hair, your nails, and the immune cells that are inside of those two. Those are the major structures that are in there. So those 3 are organs: skin, hair, nails, 3 organs that work together to protect you. Right? A shark's skin is for protection, but it's also for camouflage. So the first thing we want to look at or feel, I love this. So if you take and you feel the shark like you're petting it, nice sharky, nice sharky, nice sharky. It's smooth, right? Nice and smooth. When it goes through the water, it's super aerodynamic because it's torpedo shaped and the water just slides over. But feel the other direction. Feel from the caudal to the cranial side like this. Can you hear that? I don't know if you can hear it on mine, but it's that scratchy. It's like a cat's tongue, right? It's kind of, I'm not a cat fan, so it's gross to me, but you might like that. The reason it's like that is because the skin is not like our skin. Our skin are individual cells that butt against each other. So they touch each other and they're glued together like that. So it's nice and flat. A shark's skin is made of cells that overlap, like shingles on a roof. So if you look at this picture, you can actually see this one overlaps that one overlaps that one overlaps that one. So that when water flows in this direction, it's nice and smooth. But when it goes backwards, it's called turbulent, and it catches or causes friction. So sharks don't swim backwards very well at all. In fact, I don't think they swim backwards at all. Sharks have a problem stopping, so I can't imagine them putting it in reverse very easily. Another cool thing about these and the way they're designed is they're actually called denticles. So denticles are, they're scales, right? So, or like shingles on a roof that overlap. But the name tells you a little secret. Denta is the prefix for what profession or what medical term. When you go to the dentist, right? So, holy cow, a 32-inch shark, that's a record. Almost 3 feet. I just, every once in a while I look over at the chat box. But and I'm totally distracted. Dentist is referring to teeth, right? So these are actually little tiny teeth over the entire surface of the shark. For real. If you look at a shark's denticle and you look at a tooth, so here's your tooth, right? Nice molar there. So this actually has, an outer enamel, just like this has an enamel. It has a pulp cavity, not like a rotting cavity, but it has a pulp in the middle that's hollow. This has that hollow center, and in between it has something called dentin that's like concrete. We call it a matrix, but it's like a maze of concrete that gives it strength. Each one of these denticles, if you cut it in half, has the same structures as a tooth when you cut a tooth in half. So it makes a lot of sense. It's hard, it's strong. Why would that be good for a shark to have this like armor of teeth over its entire body? Think about your shark, you know, you're holding, well, one person has a 32-inch shark. So you've got a shark that's 3 feet. Is that the biggest thing in the ocean? No. Is that the biggest thing hunting from the ocean? Absolutely not, right? So whales could eat these things. When these are babies and they're only a couple inches long, birds can swoop down and grab them. But this armor makes it harder for other animals to chew it or bite it. It's just like a knight in medieval days. They had that chain mail, which is a bunch of steel rings that were connected to each other so that if they got hit sideways by a sword, it protected them. It's the same thing with the shark. If they get attacked by another shark or another dangerous fish, they've got this armor. This shark also has those little spikes, those needles, right? So if another fish attacks it and bites it, it injects that fish with its poison. Kind of cool. I got to quit using the word poison because it's not poisonous to humans, but it is poisonous to other fish. So it's interesting. All right, so denticles. And then the last thing about the integumentary system is the color. So the color of the sharks is an accident. The color of nothing is an accident, right? When you look at a shark and you think about where a shark swims, it's swimming along. So you've got this dark, dark ocean down here, right? And the shark's swimming along. What did I say one of the shark's predators or something that likes to eat sharks, little sharks? Birds, right? So when a bird's flying over and it looks down, it sees the dark, deep part of the ocean, but it also sees the dark skin on the top of the shark. So it's hard to see exactly where that shark is. So this makes the shark kind of camouflaged in the deep ocean. But if you're a shark's prey, what you want to eat if you were a shark, where's the shark's mouth? On the bottom, right? It's not on the front like us, it's on the bottom. Its prey is typically below it. So now your shark swimming along, you've got little fish coming along like this, right? But the little fish are looking up. What's above the water? Beautiful sky and a sun. So you've got this bright sun shining light down. The little fish is looking up and all they see is this white pale bottom of the shark and the sunlight coming down, right? So now the shark's camouflaged against its prey so it can hunt its prey better too. Super, super killer, right? It's protected against its predators, but it's also protected from the vision of its prey. Super cool design. Sharks that don't have to swim all the time, the ones that kind of linger in the bottom, that have spiracles or move slowly, sometimes they have spotty patterns to blend in with the floor of the ocean too. If you looked at any of the pre-lab stuff, there was that shark that can walk on land. If you look at its pattern, it matched the rocks that it would by the beach where it would walk on. It's crazy. Okay. Next, locomotion. This is two systems. So you have the skeletal system and the muscular system. Skeletal system, there was something unique about it. Do you remember what's so unique about a shark's skeleton? It's made of cartilage. So cartilage and bone, if you look under a microscope, are almost identical. They have the same structures. So a bone cell and a cartilage cell look almost identical, except a bone cell has big storage areas of what mineral? So what mineral do you need to take in to make your skeleton nice and hard? We drink it in milk. Interestingly, it's really high in broccoli. So when you eat broccoli, it's full of this. So you should eat more broccoli and drink milk. Calcium. So calcium makes our bones hard. A shark still needs calcium. It just doesn't need the same level of calcium because it doesn't have the hardness. You have cartilage all over your body too. In fact, just in your face, don't touch your nose now, but if you think about it, when you wiggle the tip of your nose, that's cartilage, right? You bend it to the left and you let go of it and it snaps right back. You tug your ear, you let go of it, it snaps right back. So we have cartilage all over the place where it's needed to be flexible. In between your bones, like at joints, cartilage. Right? Your ribs, helping hold them in place so that you can breathe in and out, move better than bones, cartilage. Okay? In between your vertebrae so that you can bend and bounce, cartilage. So one of the coolest things about a shark's skeleton is its flexibility, cartilage. A shark, you can watch them, they can't stop, right? So when they want to turn, they can't stop, back it up, and then turn like parents driving a car. They will actually go and they do a quick U-turn super fast. Right? Super fast. I wish I could move the shark that fast. But super flexible. You can bend it back and forth all over the place. In fact, when they wiggle kind of like a snake. If you look at the skeleton, the layout of the skeleton, you can see paired appendages. So it has fins, the pectoral fins that are like our shoulder girdle. And girdle is just the term describing all the bones that make up the shoulder. We have a pelvic girdle where our hip is. They also have pelvic fins on their pelvic girdle. So the way that our bones come across like this, they also have that same ring down here. And we're going to cut through it later when we get into the internal organs. They have a rib-like structure, so do we. Our ribs come all the way around to protect our lungs and our heart. Their ribs only go out a short distance out here to give structure for holding on the muscles. So when you feel the muscles in the shark all the way along here, it's like a hot dog or a sausage. It's super meaty all the way along here, kind of flabby down here. There's muscles, but not as strong. These are all muscles for swimming. When a shark swims, it twitches quickly. Right? You've probably seen fish swim. It doesn't use its caudal fin, the tail fin back here, for swimming. It uses its fins to do things like steering or to keep it from spinning. It's a torpedo, right? So it would spin if it didn't have a dorsal fin. So all the fins do are really steer or guide it and keep it from losing control. All the swimming power is actually in the muscle of the wiggle, kind of like a snake. Snake doesn't have any legs, arms, or a special tail. It uses its muscles and scales to actually move. So the skeleton of the shark is pretty super cool. When we look at the skull of the shark, it's called a chondra cranium. Chondra means cartilage, remember? Cranium means skull. So where our regular skull is bony, this one feels hard, but we're going to cut into it later, and you're going to see when we peel the skin off, you can see through and see actually brain right through the quote-unquote bone. So pretty exciting. We do a little bit of learning, and then we do some dissecting. And a little bit of learning, and then we do some dissecting. Get our hands dirty. Oh, my pages are sticking together already. All right, next system, nervous system. Here's where we start doing some cutting. So the nervous system has 5 senses, just like you and me. You remember yours? You have smell, sight, touch, taste, hearing. Where are most of your senses? Where are the receptors for most of your senses? They're mostly in your head, right? Well, I guess figuratively speaking. But you think of your sensations based on your head, your vision, your hearing, your touch, your smell. Lots of head structures, right? Sharks are a lot like that too, except they have 2 extra systems that you don't have, or sensations that you don't have. So let's start with the first one, smell. We already started talking about smell just a little bit. And smell, a shark can smell a drop of blood across an Olympic swimming pool because its sensors in its nose are just like a bloodhound's. And a bloodhound, if you remember watched a movie with a bloodhound when they're hunting, they turn their head back and forth, right? So if they're smelling for a rabbit, and rabbit's over here, they start way away from the rabbit, wherever it's at, and then they twist their head a little to the right, to the left, to the right, to the left. And what they're doing is they're smelling. Wherever that rabbit went, it left a stink trail. And the stink trail is strongest right here. So when the bloodhound smells to the left, there's not a lot of stink particles. When it smells to the right, not a lot of stink particles. When it smells the middle, it knows to go that way. And it can smell fast and move quickly because its nose is so super sensitive. A shark is exactly the same way. You're actually the same way too. You can detect about 10,000 different scents in a fraction of a second. But we use our vision way more than other animals. So when you smell something, here's how your smell works. That particle goes into your nose, it sticks to the top, and it activates a receptor that tells your brain you're smelling whatever it is. So here's the bad side. You step in dog poop, right? You smell the dog poop, it's too late. If you step in the dog poop and you feel the mushy on your foot, pull your nose and run, right? Scraping your foot all the way. But once you smell the dog poo particles have actually drifted into your nose. They stick to the top of your nose on a little receptor area inside your nose. That receptor tells your brain, hey, it's dog poo. Don't smell it. Too late. That particle's in your nose, so you can do two things. Do you remember what they were? You can blow it out into a Kleenex, or the mucus will actually break it off, and then it'll go down your throat, and you'll swallow it, and you'll eat that dog poo particle. Just saying. So, like I said, my favorite thing is actually moments. So when someone goes, oh, I stepped in dog poo, and they go, actually, you also just tasted and put it inside of you too. And then you go away before you smell the dog poo. Oh, stinky things. You ever had a friend that says, oh, it smells terrible, smell it. Why would I smell it? You just told me it smells terrible. And actually, now that terrible smell is inside of you. See ya, sucker. Okay, psych, next one. Like I said, the eyes of a shark are the most similar to a human of all the fish. In fact, the shark's eyes are very different than most other fish. So we put a picture of a human eye in here for a good reason. A shark's eye has all the same things that you have in the eye, except two things. First, unlike other fish, a shark has an eyelid. You have an eyelid, but a shark only has a lower eyelid. So, and you can see this in shark videos, when it's about to attack and opens its mouth to bite something, its eye blinks. So its eyelid comes up and covers on both sides so that that thing can't poke it in the eye or hurt its eye. That's the first thing that's different. It has one eyelid instead of two. The second thing that's different is at the very back of the eye, way back here, light will pass through all the structures of the eye, be detected on what we call the retina, which is like the camera of the eye. And that's where our vision stops. But with a shark, the light goes all the way through, takes a little bit of a picture, the light bounces off this back layer that's called the tapetum lucidum, which I think is written in here. Yep, right there. Tapetum lucidum. And it means light tint is what it means. And then the light bounces back and hits those receptors a second time. So it really gets two snapshots of one picture, so it sees in better detail. You know a lot of other animals that have that. In fact, humans are pretty rare that we don't have it. But when you're outside at night and you're shining a flashlight and you see a raccoon and its eyes glow, it has a tapetum lucidum too. When you see your cat and you shine the light and its eyes turn like green or yellow, that's the same thing. Creatures that hunt in the dark or eat in the dark or walk around in the dark a lot have this extra layer that reflects light back. It's actually a layer of little tiny mirror-like crystals that are different colors to bounce the light. So like my dog, I have a bouvier is what they're called, but her eyes, when I shine a light at night, she looks like evil because her eyes are actually this color, this reddish orange, and it's scary. I have a friend that has a schnauzer, and his dog, strangely, it's this color, it's teal. So when you shine the same flashlight, my dog has this like evil reddish orange, and his dog has this teal color, pretty blue. Cats can be green or yellow. Trying to think of other things I've seen. Goats, I've seen goats that have like a greenish color. Humans, if you've ever shined a bright light in their face real quick, like with a camera and took a flash, and their eyes glow red, it's not because of this, it's because the back of your eye also has blood vessels. So the light comes in, bounces off the blood vessel, comes back, and it looks red. So there's another fun fact for you. All right, let's actually dissect the eye and look at the structures. So here's what we're gonna do. First of all, in this picture, you're missing it. I normally like to dissect it later, but I want to start dissecting now. There's a picture of the eye back here. You have 6 muscles that hold the eye in place, and we're going to try and make sure we preserve most of those. You have one that turns the muscle or the eye to the left, one to the right, one that turns up, one that turns down, and you have 2 of them that actually twist your eyeball, like spin it, which seems weird and it's hard to see, but it's only when you're falling that you use those. Long story. But there are 6 muscles that steer your eyes in little tiny movements. So we're going to try and preserve those. The things you're going to look for are first the cornea. The outside layer, the clear layer, is called the cornea. That's where light passes first. Your eye is filled with fluid. All this area back here is called vitreous humor. It's a fluid that's a little kind of jelly-like that keeps your eye round. When you die, that water in the jelly seeps out and actually goes from being round like a grape to more wrinkly like a raisin like you're looking at here. So that's right why the eye kind of collapses a little bit. So the first thing was the cornea. The second thing is a pupil. And the pupil is actually the absence of stuff. There's nothing there. It's actually a hole. And this whole area right here that you can see right through, that's the pupil. The dark area around the outside is the iris. In humans, we have blue irises or green irises or brown irises or just a blend of it. So in reality, you either have no pigment here and you have blue eyes, or you have a greenish brown pigment, which gives you green eyes if you have a little bit and brown eyes if you have a lot of it. So the color of the eyes are really kind of cool. And we do that, we talk about that more in another class that we do. But you're going to cut through the pupil. You're going to identify the iris, which is that little thing that adjusts the size of the pupil. So in bright light, it squeezes down, constricts, and dark light, it opens up, which is what makes a shark also like a human, is that most fish don't have a pupil. Most fish just have a big open eye, and it's always bright. But a shark goes up to the surface where it's bright, and it has to be able to squeeze its iris and pupil down, and it goes down deep into the ocean where it needs more light, and it opens it up. So very unique. They're a great hunter. Right? We're going to pull the eye out. So to do this, you're going to grab your scissors. Oops, like this. You can see that if you just close the scissors and go over the eye, there's a gap all the way around the eye, right? When you open the scissors, just put one side in and kind of push towards the middle and snip, cut. Do the same thing back behind the eye. So we're going way back to the back. We're going to go to the center, snip, and cut. So now I have two little cuts above the eye. And the eye actually has a wrapper that goes over the whole thing. It's called the conjunctiva. Big fancy word. But sometimes it's good to know these big fancy words, because if you know the fancy word and you know the little pieces that we add to words, you can tell what's wrong with it. So if you put itis at the end of any medical word, it means the swelling of that thing. So if you have conjunctivitis, it means that all this stuff around your eye is swollen, and you actually have kind of a reddish pink looking eye, and we call it pink eye. So conjunctivitis is a swelling of this layer, and we call it pink eye. All right, I'm going to use my tweezers for grip because my gloves are a little bit oily. And I'm going to pull a little bit. And that's the only benefit to the eyeball being kind of dehydrated, is because I can grab hold of it. And I'm going to cut all of this conjunctiva up as close as I can to the body and away from the eyeball. So snip, snip, oops, there's a little hole there, snip, snip, snip. Because what I want to do is I want to see behind it, and I want to see those muscles. So as I open it up, whoops, let me get another grip. There we go. I can see there's a muscle right there. Can you see it? It's kind of a pinkish gray color. That's a muscle. Let's see, here's another one right here. Whoops, it's still in the conjunctiva. See if I can clean some of that off. Well, you can see it. It's right there in the center. Move this over just a little bit more. I'll do a couple more snips, but I'm cutting really close to the shark's body because I don't want to cut those muscles. I want to see the muscles. Part of dissection is just kind of being patient and exploring, see what you can find. So I know I'm cutting the wrapper, the conjunctiva, but I'm trying to avoid the muscle. Did you notice the way that it sounds when you cut the skin? Right, a little bit more down the bottom. And as soon as I get down here, I'm kind of pulling. Yep, I'm feeling some muscles. Snip. Snip at the back. I'm just going one little bit at a time. I'm pulling it up a little bit, and I'm looking for whatever's connected. I wish I had a little bit better light in there. There's another muscle. And what I'm really looking for is when I get all the way to the back, there will be something that is holding it on, but it's not pinkish gray. It's more of a white in color. And it looks like a little tiny wire. I see it, and I just cut it. And did you see when I cut it? the eye really kind of popped out. It's that white cord right there. So if I put this over the picture, like this, that little white cord is that thing that sticks out the back, and that's called the optic nerve. And the optic nerve takes all the photos from this light camera and sends them to the brain. So what's cool about our vision is that we have two eyes, right? So both signals are coming into the brain from two different perspectives, which gives us 3D perspective, so we can see things in three-dimensional. That's what makes us really good at driving cars. Compared to a lion, that may not be the best at driving a car. Or a goat would be terrible because a goat's eyes face sideways, right? So driving a car, they'd be great at seeing things to the side, but what's coming at them, maybe not so much, right? But this little optic nerve sends all the signals from each eye to the brain to take those two pictures faster than you can even think about it and tell you what you're seeing. Okay, the next thing we're gonna do, this white layer on the outside, you can see some of the muscles. Oops. The white layer is called the sclera. And what it's there for is to keep light from coming into anywhere except the pupil so that you can focus light. You know, it's the same idea as a laser. There's a muscle, there's a muscle, there's a muscle, here's a muscle, another muscle, and then back to the optic nerve. Let's cut in. Let's check this out. So there's the sclera. This is all cornea. You can see the iris down there. And here's a trick. You don't want to squeeze the eyeball. I'm just telling you. And I have to talk the whole time, so there's no way that I'm going to squeeze the eyeball because sometimes it squirts. It's like a grape, right? If you squeeze it too hard, it squirts out. So I'm just going to pinch right here at the front. You can see there's the cornea. I'm just pinching it. And if you want to pinch it with your tweezers, that's fine too. In fact, that's probably a better idea for me. Pinch with the, whoops, so tweezers didn't grab it. Let me flatten it out. Tweezed, got it. And then where it's flat gives me an opportunity to cut with my scissors, right? So I'm just gonna cut that flat part. Snip, I just cut it. I heard it go through, and now I can open the eye. I'm gonna put my scissors back in. I'm gonna cut again, and I'm gonna do what we call a clamshell. So imagine a clam. I'm cutting, cutting, cutting to the back, and then I'm gonna do the same thing to the other side. So that when I open it, it's like opening up a clam. Clam, clam, perfect. See, now I can open it like a clam. I can see some of the, I'm gonna grab my probe. I can see some of the iris right here, and a lot of these things will start flaking off. When you're alive or when a fish is alive, remember this is a round, like full of fluid and nutrients eyeball. But when it dies, things start dying and falling apart, right? It's like anything else. You have a tree that dies, the leaves fall off. So I can kind of scrape some of the iris back. But I can see there's the pupil, here's the iris. Pupil, I can see the tip. Over here is the iris where I can't see the tip. Next, that ball is the lens. And normally your lens is very squishy. It's kind of like a gummy bear, but it's round and it's attached with little tiny muscles that we can pull off easily since it's not alive anymore. But it's squishy. Once you die, and it's clear by the way when you're alive, but once you die, all those nutrients stop coming to it and it clouds over and it turns hard. So you can feel it's like a rock. My 7-year-old is actually my guinea pig for anytime I want to do a new dissection. And as soon as we started going in the truck, she's like, let's cut the eyeball, Dad. I'm like, oh my gosh. So aggressive. Because she knows what a lens is like and she thinks it's the coolest thing ever. So there's the lens. Right? If you pull back on your clamshell and open it up, you can see the retina is this dark area in the back. right where the optic nerve comes in, on the other side, the retina is a lighter color and actually has no light sensors. So you're blind in that one spot. All the other areas of the retina, the back layer, have two types of camera receptors. You have something called a rod that detects light and darkness, and you have something called a cone that detects colors. I always think of snow cones and colors. And like I said, this is a whole other class, but you can really only see three colors: red, green, and blue. There is no yellow, there is no orange, there's no indigo, purpley color. All those are made up. There's no browns. Your eyes see three colors, and everything else is made up by your brain. And like I said, that's another STEM class. Hopefully we'll see you there. But this retina is interesting because a lot of the things I read about sharks, they say they only see black and white, which means they have what? Rods or cones? Cones, snow cones see color, so it's got to be the rods. But I actually read a textbook that said that there are different cones in the back of a shark's eye, but they didn't say what they were sensitive to. So what colors are they detecting? They have to detect some color. If you ever watch dog TV, it's actually a TV station made for dogs because dogs only have two colors they can see, two cones. And so this whole TV screen is based on those colors for a dog. Kind of cool. Okay. But that's the eyeball. There's so much more we could do with the eyeball, but we just don't have enough time to do it. Okay. Touch is the next one. Your body has the most sensitive parts for two places for touch: your fingers and your, do you remember? Your lips, right? When we talked about the baby. Sharks are the same way. Not their fingers, because obviously they don't have fingers. Oh, but their lips. Not real lips, but the mouth. Their mouth is the most sensitive part to touch on their entire body. So, which is good for them because if they get bitten, they don't feel the pain like we would. They turn around and attack and fight. But their mouth is super sensitive to touch, so they can feel with their mouth. Bad for you, or bad for anything they want to feel, because when they feel with their mouth, they also feel with all those teeth, right? So when sharks attack, they don't usually attack people because they're trying to hurt us. They bite us because they're curious about us, and they nibble on us. My dog does the same thing. She'll nibble on me when I tickle her, right? Shark does the same thing, but it has 6 rows of teeth in here, 3 on the bottom, 3 on the top, right? So it's going to shred whatever it nibbles on. Usually sharks, when they bite us or attack us, it's not a true attack, it's an accident. So most shark attacks are not fatalities. People don't die from them most of the time. People do die, and that's terrible, but most of the time the shark will bite and it goes, ooh, this is not what I thought it was, and then swims away. From what I've heard, and I'm not another animal in the animal kingdom, but I've heard that other animals don't like the taste of human. We taste terrible. That's why a lion can attack you and kill you, but just leave you there and not eat you, even if they're hungry, because they don't want you. I don't know. I don't know if we taste like snails, or maybe snails are delicious and we just don't know it. Who knows? But their touch sensation is highest around their mouth. So they like to nibble and touch things with their mouth. Taste, their taste is really good too. Not as good as their smell, but their taste buds, if we prop open the mouth, so if you use your tweezers, we don't want to rip open your gloves. If you do rip open your gloves too, I forgot to mention this, you can use your plastic, the jump simulation bag. You can put your hand in that bag, take the glove off, put the hand in the bag to feel things or to grab things like a mitten, or you can use a Ziploc bag or a grocery store bag or whatever to put it in. It's not as good as the gloves, but it will still give you the same, sensation. So let's put the tweezers in instead of our fingers so you don't rip a glove. And if you pull it back, whoops, my tweezer spun. If you pull it back, the tongue, remember, is firm. It's just a slab of cartilage. All it's there for is to smash things. So when it bites a fish, it just smashes and pushes the fish onto the roof of its mouth. And the roof of its mouth is actually where its taste buds are. Not like you. You have taste buds on your tongue and on your throat. If you didn't know that, they're also in your throat. But a shark has them across the roof of the mouth. So it has to bite and chomp and smash to really taste things. So hopefully it feels you with its lips and says, oh, I don't want that, instead of just chomping on you, smashing you. Right? And then the last one, hearing. So with hearing, this is hard to see. In fact, about every other shark can I even see it. A shark's ear, our ear, here's what it looks like. We have an external ear, which you're familiar with, that gathers sound waves, goes to the middle ear, And then the middle ear amplifies the sound into the inner ear, which is the cochlea. Sharks only have inner ear. Hey, Taylor, can you grab my laptop power cord? It's on my desk over there, plugged into my dock. Sorry. Yes, thank you. So their inner ear is all they have. They don't need the external ear and the middle ear. They use water pressure that hits the walls of their head to vibrate this cochlea and tell them what they're hearing. So when you hear a high-pitched sound like I don't even want to imitate it, but like a singer that sings a high note, sharks don't hear that. Sharks hear the low bass. So when you hear that bass come by, boom, boom, boom in a car, they can hear that great, better than you. And it's because when you're underwater and you're hearing people talk above water, what do you hear? You hear like this real bassy muffled sound, right? That's perfect for sharks because that bassy muffled sound actually travels further away than the high-pitched sound. So if you hear a car coming on the road, you usually hear the boom, 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 boom first. Then you start hearing the words to the music, not the other way around. So sharks can hear for a long distance. They can smell from a long distance. They can hear from a long distance. When they're in the deep ocean, they can see a pretty reasonable distance for being, well, deep in a dark ocean. Sharks have really amazing, like, senses, and they're not even done yet. So if you look, you might be able to see, and I know I'm touching this with my fingers. I had to move something again. You're going to look right up in this area. So here's a spherical, here's the eye. It's usually right up here, like if you made an X. There are two little tiny holes, and those are just for water to flow through. Yep, I can't see them on my shark today. They're for water to flow through so that, my engineering desk over here, just to let water move back and forth. Equilibrate's the proper term. I'm trying to think of a generic term. But when this device in your ear, your cochlea, moves, if there's no water or air that's able to move it, it doesn't vibrate at all. Even ours has fluid going around it. So again, hearing is amazing. And then there are two more sensations that a shark has you don't have. One is pressure. Remember that lateral line? Where's it at? Lateral gives it away. It's on the side. There's the lateral line going down. That line is actually filled with little teeny tiny holes. And those holes let water go into them, and there's a sensor on the bottom that detects water pressure. So if a shark is moving along, and my finger's here, a shark can actually feel as it pushes water off its body to my finger and back, it can feel how far away I am. Have you ever done that? Like you close your eyes and you have a friend put their hand close to your face until you can feel it? It's kind of like that, except in the water, the shark can feel it. Another example is a bat. When a bat puts out echolocation, sends out sound, bounces back, and the bat hears it to know how far away rocks are or bugs are. When a shark swims, it can swim in rocky areas in the darkness, and it knows how far away the rocks are. Same idea. You ever seen a shark circling something? So when they circle, just go around in circles, they might be circling something. If it's a fish in the middle, they might be going around it just to get an idea of how in the middle that fish is. Which brings me to the last sensation. This is probably the coolest weapon that a shark has. It's called electroreception. If you look at the rostrum, which is the nose of the shark, you might see little tiny holes all over, like little pinholes. The same here. If you flip it over, sometimes on the white side, it's a little easier to see. But see all those little pinholes? Those are kind of like the lateral line. They're little tiny holes, but they're filled with a jelly. And that jelly is electric sensitive. So if you have heard of somebody having heart problems and they go to the doctors and the doctor hooks up pads to their chest that have gel on them, that gel actually makes it so that we can detect the electricity in your heart. So every time a muscle moves, it releases electricity. It comes to the surface and it goes down the wires to tell the doctor, where the electricity is moving in the body. We could do the same thing with your arm. So any kind of muscle that moves, we could actually do the same thing with your brain. But a shark has natural receptors built into their nose, just like that. So if electricity is near them, they know it's there. And you're probably thinking, oh, electric eels, but actually no. When a shark attacks something in the dark and it doesn't know if it's killed it or not, what can it detect? I kind of just gave it away when I was talking about the hospital. So if a shark wants to attack something, it bites it and grabs a hold and just rips and tears at it. How does it know when the thing's dead? Its heart stops, right? The shark knows when the electricity in the heart stops of its prey. The same thing with if a fish is sitting perfectly still, a shark may not be able to sense their heartbeat, but if they twitch a muscle, then the shark knows it twitched the muscle. So when the muscles quit moving and the heart quits moving, the shark knows that it's killed its prey. That was really cool. Like I said, the sharks, we talk about them being some of the best predators, and that's really true because they have perfect weapons built in. Great armor, super sensation, right? Reproduction is another thing. So the next system is reproduction, and it's a lot like a chicken. That's why we put a picture of the chicken in here. Remember how I talked about the cloaca, the hole down here that they can poo out of, urinate out of, have babies or pups out of? It's just like a chicken or a bird. Birds do the same thing. They have one hole that they poo, they pee, they lay eggs out of, all a common hole. Sharks, man, if you didn't look at the pre-lab, this is definitely worth looking up. Sharks are interesting because they can reproduce in lots of ways. Like with humans, we have live babies. That's what we do. You know, sometimes we have a twin. With chickens, they hatch or they lay eggs that hatch. That's what they do. But sharks can do both. So some sharks can actually develop eggs inside of them, push them down and drop them out of the cloaca and into the like seaweed around to hopefully protect them. Some sharks make eggs, but they hold the eggs inside of them. When the eggs hatch, then the babies swim out, the pups swim out. Some sharks have live babies inside of them, just like a human does, where the baby's in there moving. So they can have 50 pups inside them wiggling the whole time. Then when they're ready to swim out, they can swim out. And this is probably the coolest, grossest thing about sharks. If you did the pre-lab part, you already know what it is, but it's called intrauterine cannibalism. Cannibalism is when one animal eats another of the same kind. So if you see a frog swallowing another frog, it's a cannibal. If you see a fish swallowing another fish, it's cannibal. Shark swallowing another shark, cannibal. Intrauterine means that the uterus is where the babies are developed. Intra means within. So this is crazy. One shark, and a tiger shark is actually an example of this. And it's kind of ironic that it's a tiger shark because we always hear about tigers doing mean things. But so the tiger shark can have 50 babies on this side of its body inside, 50 babies on this side of its body on the inside. But as soon as one of the babies gets to about 4 inches long, it will eat all of its other babies. So the shark on this side, the baby shark, will eat the other 49 baby pups. Shark on this side will eat the other 49 baby pups. And when this shark gives birth, it gives birth to twins, just 2. Even though it had 100 sharks in it at one time, it only gives birth to 2 sharks. Crazy. Man, my brother is so lucky that humans don't practice intrauterine cannibalism. Because I used to be so much bigger than him. Now he's about the same size. So it's a fair fight. Okay, reproduction. Oh, the last thing is you want to find out if you have a male or female. So here, where you looked at the cloaca, these fins are called the pelvic fins. And if you have a male shark, you have the pelvic fin, and there's a little slit here and an extension on the fin on both sides. Here's your pelvic fin, a little slit, and an extension on the fin on both sides. That's the male reproductive organ. If you have a female, you just have the fin, and that's it. It just comes back up. That's how you tell. So when you're watching TV shows and you've got that Australian guy's like, look, he's a big one. And he says he, but then there's no little pieces on here, you know, that guy didn't do his homework, right? Because it's a female shark. And most of the sharks that you see that are coming close to cameras and stuff are females. Watch for it. Kind of cool. All right, now we're gonna have to cut into the shark. So make sure you've got your gloves clean, ready, whatever. We're gonna look for the respiratory system. Respiratory is talking about breathing, right? So they don't have a lung system like we do. If you look inside the chest of a shark, when we cut it open, you're not gonna see a set of lungs. Sharks breathe with their what? The gills, right? So when we look at the gills, here's the outside of the gills, kind of what it looks like on the inside. We're gonna see some light bony structures that protect the gills, right? So when we go into the gills, we're gonna look at the pathway where air flows over. And here's how it works. Ready to cut? Grab your scissors. And the directions are right here, but they're in the medical terminology. So it says, using your scissors, cut from the left lateral corner. Where's left? Here's your patient. here's my right, here's the patient's left, okay? So I'm putting it up here just to show. When we talk about the left and the right, you always talk about your patient's perspective. Here's the left side of the patient. So when we say the left lateral, here's the left side, here's medial, there's lateral. So it says left lateral corner of the jaw. We're gonna cut caudally and medially. So caudally means we're going where? Towards the nose or towards the tail? Towards the tail, and medially to the gills. We're not gonna cut the gills. So that means we wanna be on this side, towards the middle from the gills. So we're gonna cut along here, medially to the gills, all the way down to the most cranial proximal corner of the left pectoral fin. Left pectoral fin, most cranial, proximal. Remember, distal is far away, proximal is close. So if you feel here, there's a joint, just like your shoulder. That's where we're gonna cut to. But we're gonna make sure we don't cut the gills. So we're gonna cut here, all the way down, right to that joint. Once we get that done, we're gonna pause, open this up, look a little bit, and then we're gonna cut transverse, which means across. Okay, so I'm gonna position my shark like this because I'm right-handed. You can do it the other way, it's fine, but you still wanna cut the left. When you cut in, open your scissors, wiggle them in. Actually, this will probably be better. If you take your tweezers and kind of slide them into the mouth so that it holds it open. All right. Snip, snip, snip. You're gonna push them in as far as you can, but you're not gonna take long bites. You're gonna take little bites because you have to snap through the jaw. It's not bone, it's cartilage, but it's still hard. And so you're gonna squeeze. You feel the crunch? A little bit of a crunch. Here, crunching again. So it took me almost 3 bites just to get through the jaw. All right, I'm through, I'm taking little bites. Remember, I don't wanna cut the gills. I wanna cut medially down to the pectoral fin. So I'm gonna cut a little bit more. Oh, that's not a good sign. I've used these scissors probably on 10 sharks and they finally gave out. It's a good thing you only have to cut with one. All right, had a backup. The backup. Taylor, right across the hall, there's a box of the scissors that they have. They're way better. And that's why we don't use these scissors anymore. We used them on the first couple runs that we did, and then we had a couple break, so we quit using them. If you do break them, if you do break your scissors, and it's okay with your parents, you can use any pair of scissors. You can use some from the kitchen or whatever, and you throw them in the dishwasher and they're hopefully safe. Right, so these are probably more like what you have with the rounded tip, a little bit shorter. These are pretty awesome. Okay, snip, snip. And now I've cut in here. What I'm actually gonna do is I've cut into the jaw. If I keep cutting this way, I'm gonna cut down into the stomach. I don't really wanna do that. So you can see I have a little hole under the skin. I'm just gonna poke this into that hole and snip, 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 snip. I can feel it giving. Not cutting the gills. There we go. Little bites with the back. You see it peeling open. Just gonna go in a little bit more. Snip, 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 snip. A little bit more. Snip, snip. And I can see each of the gills as I do this. So out here on the front, we're just seeing the gill covers. Inside, we're actually seeing the gills that go deep. Okay. And then I'll go up this way and finish it off. Snip. Yeah. So I've opened this up. I can see the gills on the inside. 1, 2, 3, 4, 5 gills. I'm just going to cut a little bit more right here. There we go. Freed up the mouth. And I've left these gills intact. Here's another trick. When we're done doing this, you can dissect all day if you want, as long as it's okay with your parents. I'm going to show you how to wrap everything up when we're done. But one of the fun things we don't have time to do is the skin. So if you notice the kind of like crunchiness of the skin, this skin, and also that sound, skin used to be, from sharks, used to be used as sandpaper because it's really fine and it stays coarse or very aggressive for a long time, so they could polish gems like diamonds and rubies and emeralds and stuff, or wood with it. So what I like to do is I like to look under the skin, and if you find a little hole, take your scissors while they're closed, kind of wiggle it in under the skin, open it, pull back. I have a hole, wiggle a little further, open it, and pull back. I'm not cutting the skin. Every organ in the body has a wrapper, and the skin is the big wrapper. And in fact, right now, I'm just kind of poking around. You can see my scissors under there. If I open and pull back, wiggle, open, pull back. But every organ has a wrapper. The skin is a wrapper for the whole body. So if we kind of separate the skin by getting in between the wrapper for the skin and the muscle, and separate, and separate. And this is actually, surprisingly, a really important surgical technique. Everyone thinks, oh, surgeons, they love scalpels and they use a scalpel on everything. No. When we're teaching anatomy at the med school, it's really hard to get the med students who are going to be doctors to put their scalpel down because they think they need to cut everything. But in reality, your body doesn't like to be cut. So a good surgeon doesn't make very many cuts. What they'll usually do is they'll take their scalpel and cut the skin, kind of like you did. They go under the skin or around the organs, and they'll take their fingers or a pair of scissors like I'm doing now and separate, not cut, to separate. So I can take my finger in here. Whoops, let me separate a little bit further. I'm just going to slide it up like that. Now my fingers can go completely under the skin, and I can feel it all the way down here. And now I can feel to the other side. I can feel the muscles. If I flip my finger over and push down, I can feel the muscles in the chest. Those big, strong pec muscles, right? I can slide all the way up. I can actually feel, there's the chest. Like we talked about your breastbone, your sternum. I can feel it right there. Sliding up, I can feel the chinny chin of my shark. I can feel all the way across. And doing this, if you're ever helping your parents cook supper and you're making chicken and you have to remove the chicken skin, this is exactly the same thing. So now watch. I've separated the skin. I can go straight across the skin with ease. Boom. If I want to look inside or at the muscles underneath, I've separated it. And you can see all of these muscle groups. You can see each of these individual muscles and the directions that they're flowing. Pretty cool. If I come up this way, I peeled back, I can actually look at where all the gills on the inside attach. I just did that by opening and separating. Open, separate, open, separate. Just like this. So I can see the muscles in the chest. I can feel that bone underneath. Feel it all the way down here. Now what we're going to do is we're going to feel that bone, whether you took the skin off or not. You feel the bone, it drops, it's squishy here, firm bone, muscle. I want to feel that bone and I want to cut right above. So superior or cranial. Had a problem thinking there for a second. I kept thinking human terms, but cranial to that bone. So I'm going to cut here, cut, snip, cut, snip, cut, snip, cut, snip, cut, snip, cut, snip. And I'm cutting kind of like an arch, but I'm cutting right over to the side, the same place. And you could cut right through the bone. It's just a little bit harder. So I'm cutting, cutting. Right. In fact, I'll show you. I'll cut through the bone. You hear the crunch, the crunch, 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 crunch. Okay. And then I can open here. And I can just peel. If there's anything else you needed to cut, you can do that. But we're trying to open up right underneath that breastbone, the sternum. Now I can see the heart. Ba-boom, 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 ba-boom. Right. I can see the tissues of the gills. If you look at the gills and you pull back, you can see that they have little lines. They're like pages of a book, like this. And the water has to flow between each of those pages because under a microscope, if you flip the page in your manual, we're going to go to 2 pages. There you go. Under a microscope, this is what they look like. Here's a page, there's a page, there's a page, there's a page. The water actually flows over each of the pages, and these little oxygen particles go into the blood. So these are really full of blood. Anytime you look at a textbook or a manual, they show blood as being red and blue. Red means it's full of oxygen. Blue means it's missing oxygen. Your blood doesn't actually turn blue. They do this because if you look at the veins that usually carry blood without oxygen, they're more blue color, but the blood itself always stays red, either bright red with oxygen or dark red without. So here's a trick. Next time you go to the fish market or you go to the grocery store and you're wanting to buy a fish and you want to get a fresh one, these gills should be full of blood. And should they be full of fresh oxygen-rich blood or old, stale, dark red blood? If you have a fresh fish at the market and you open the gill like this, you don't have to cut it apart. You just pull the gill up and look inside, and it's bright red, buy that fish. Because that fish still has oxygen in its gills, which means it was in the ocean not too long ago. If it's dark red, kind of just like a wine color or burgundy, don't buy it. Put it back and move on to the next fish. Because that means that the oxygen's all slipped out of the gills and it's been there for a while. Old fish. Okay? So that's how they breathe. Each one of these slits has to have water flowing over it going down. Let's go ahead and open this up a little bit more. Just a little snip, 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 snip. I just want you to open it far enough that you can see the tongue, number one, feel it. You can see the cartilage in the jaw. It feels hard, but it's actually like translucent. If I put my scissors behind it and have the right light, I can see where the scissors are moving. Teeth are still teeth. They're still the hardest substance. But if you take your probe, and you'll have a flattened end of the probe. It's not flat like mine. Mine's not as cool as yours. But yours is more like a flat blade. And you slide it into the spherical right here. Kind of wiggle it and twist it. Oops. There it goes. You can see it come out in the top of the mouth. And any of this extra stuff that you need to remove, you can. All of this, I don't need any of that. This is either part of its last dinner that I'm taking out, or it's the preservative that leaked through. Right, so now I can see the top of the mouth. I can see the bumpiness of the top of the mouth, kind of like a cat tongue. That's where all the taste buds are at. I can see where the probe goes through the spherical, so air, just like in this picture up here, air can flow into the spherical, into the mouth, it puffs its cheek, and then pushes the water out over the gills to leave, just like in the picture. So it can either go in the spherical or the mouth, and then goes out over the gills, dropping off oxygen and picking up CO2 and carrying it away. Here are gill filters. They look like teeth, but they're not. This is so that if a shark swallows a little fish, like a minnow or a shrimp, it doesn't go and get stuck in the gills and kill the shark, right? This makes sure that that fish gets redirected down into the stomach, or that shrimp gets redirected in the stomach. This would be like you taking a pea, like a garden pea, sticking it in your nose and inhaling, right? If that garden pea went into your lungs, it'd cause a lot of problems. If that shrimp gets into the gills of the shark, it causes a lot of problems. Right? So there's a spherical into the mouth, over the gills. That is part of the respiratory process. Collectively, we call respiratory and blood circulation the circulatory systems. So the other part of circulation is actually blood flow. And we started talking about that already, but we're going to look at the heart a little more in detail. Right? So when we look at the hearts, here's your heart. Maybe you've already studied it in school or seen pictures of it. You have 4 chambers. You have an atria on the right. Remember, this is the patient's perspective. So this is your right. This is your left. You have an atria on the top where blood comes in from the body. That's why it's all deoxygenated, oxygen poor. Comes into the atria, goes down in the bottom part called a ventricle. The ventricles are very muscular. So the atria is kind of like your thumb. It just goes squirt, squirt, squirt. The ventricle is like your fists going smash, smash, smash. And the ventricle pushes blood up and out hard over to the lungs. So your right ventricle only pushes blood to the lungs. Why would the blue-blooded right ventricle only push blood over to the lungs? I'm trying to give it away without giving it away. It's because it's trying to pick up oxygen. Yep. So the right side of your heart actually started as two different hearts. And then as they started beating with time, they squeezed into one. They stuck together. The right heart pumps to your lungs and the left part pumps to where? Well, where do you need blood, right? If the right only pumps to your lungs, the left has to pump to everything else in your body. It goes everywhere, to the tip of your toes, tip of your fingers, top of your head, all of your internal organs, like your liver and everything. It pumps everywhere. So when these things are pumping, the atria pulls a little bit of blood in, the ventricle pushes a lot of blood out. Let's see if we can follow that. So, you know, with the lungs, good new blood comes in to a what? They're the same, right? So it comes into an atria, but on the other side, the left side, goes to a what? Ventricle on the left side, and then squeezes and pushes blood out, but it pushes it up over your heart and distributes it to the whole body. That's probably one of the most famous blood vessels called the aorta, and we're about to look at it in your shark too. Checking out your shark aorta. Let's get in there. So we need to peel back to make sure we can see the heart. Oops, sorry, move that off the screen a little bit. Peel back so we can see the heart. And there's the heart. See it? We can take our tweezers. I'm using the back side of the tweezers as like a pointer. I'm going under the heart, and I'm kind of just lifting it up. Okay. So there's my ventricle. This big meaty part is the ventricle. It's like the fist of the heart. This part right above it that's kind of squishy is the atria. But we only have one of each. If you look up here, the shark receives blood in an atria, pushes to the ventricle, and then pushes out to the whole body. Not just lungs. It doesn't have lungs, right? It pushes to the gills that pick up oxygen in the blood, and then it circulates to the whole body and then comes back and does it again. Only one pump. So a little bit different than us. When you think about how big your shark is, look at that little tiny pump. This little tiny pump has to be able to pump blood to everything in the body. In about 60 to 70 beats, your heart will pump every drop of blood through your body one time. So every minute, all of the blood in your body goes through your whole body one full time. Right? Another thing that's a little bit different about this picture is that the heart isn't exactly shaped like this. It's actually S-shaped. So pushes up into the atria, it'll push down into a ventricle, and then the ventricle pushes up. So if we watch this process, I'm going to lift this heart. Pull it just a little bit more. Whoops, a little bit of juice, a lot of juice. I'm going to use my tweezers, and I'm going to lift it like this. Oops. I'll just lift it up like that and hold it. I'm going to take my scissors, and I'm going to cut the bottom part of the heart out. Ooh, wish the light were a little bit better. Hold on, let me see if I can get a little bit more light. Hopefully I don't blind you. I'm actually going to use a surgical light, which gives a lot of light. Whoop. Let's see if we can just kind of shine it over. There we go. Now hopefully you can see a little bit more what's in there. And I keep squeezing that and getting the juice out. All right, so I'm going to lift up the heart. Here are the blood vessels. They're coming in. These are veins. Veins always carry blood towards the heart, always. Remember how I said you rarely ever get to use never or always? This is one of the times. Actually, there is one exception, but it's not in your body. It's in a baby. Oops. So, whoop, I keep slipping. All right, well, I'm gonna do this anyway. I'm trying to hold it in the light, which is a challenge. You're probably having an easier time. So I've got the heart, I've got it pulled up. I'm gonna go under it like this. Can you see? I'm going under the heart with the scissors. Now I'm completely under it. That's where I wanna be. This is a vein. It's actually called a venous sinus, which is cleverly named in anatomy, sinus venosus, which means venous sinus. Now I'm going to open just one blade, and I'm going to go back in because I want to cut that venous sinus. So I'm putting my blade underneath it, and as far away from the heart as I can, snip, which wasn't all that far, snip. I'm trying not to cut the heart, snip. There we go. With that vessel cut, I can lift my heart up and out. Looks like a little tiny bit still connected. I can see it right down here still connected, so I'm going to reach in, snip, no more connection. There we go. So now the heart is almost completely out of the shark, except that last top part right there. So here's where the blood comes in on the bottom. Oops, let me center that a little bit. It goes into the atria, which is right there, that little sac. Little sac. Comes down to the ventricle, which is the meaty part here, and then goes out, the most famous blood vessel probably in the body, that one, called the aorta. So we're going to cut the aorta as high up as you can. Way up here. Snip, 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 snip. Got it. Now I have shark's whole heart in my hand. So blood will come. I'm going to take my probe out. Blood will come up from below into this aorta. See it? See how floppy it is? The aorta is not very strong. It's a floppy piece of muscle. From the aorta, it will go, oh, dropped it. From the aorta, you can kind of see where it leads down, but it goes aorta, down into the ventricle. So you can see the blood goes in here. I can kind of push on it. And then from the ventricle, it comes out of this aorta. I'm sorry, did I say aorta up here? Atria to the ventricle, to the aorta. So you kind of follow these pathways. I'm curious. I want to see what happens. I'm going to slide this. Yep, it's too small. I'm going to have to use the pen. So I'm going to slide the pen back in to the aorta, the big blood vessel on the top, till it feels resistant. Oops, sorry. Till it feels resistant. So I'm poking it somewhere down here. Now I'm going to cut the heart open and check it out. So I'm going to see if I can find that pin. Yep. Cut it open. Cut it in half. There's the pin. See the tip of the pin right there? See all that muscle? Lots of muscle in the wall. Lots of muscle in the wall. Here you can see the cavity where the blood sits. That's the inside of the ventricle. So when it squishes, it goes kind of like you in the bathtub when you take your fist and go and water squirts out of the top. It's the same idea. Your heart is so strong, it's about the same size as your fist, a little bit bigger than your fist. But when it squeezes, it could squeeze that little squirt of water 10 feet in the air. That's how strong your ventricles are. Right. This one squeezes blood up and out like this. So we're going to retrace the pathway and then see, out of the aorta, the rest of the body. I took one pin out, I'm sticking it back in. So now I have 1, 2, 3, 4, 5, 6 pins, a probe, one intact pair of scissors, and 2 busted pieces of trash. Cool. So now I've got scissors for the next 9 dissection. All right. I try to be respectful of my subject, so I'm going to put the heart up there. I'm actually going to put a little pin in it so it doesn't fall off. Kind of like collecting butterflies, right? Boom. And it doesn't matter if it's a human or a cat or a shark. You always be respectful of your donor patient, because if it weren't for them, you wouldn't be learning anything, right? Okay, so you can kind of follow. There's a blood vessel there. The blood would come up through these little vessels. Can you see them? Kind of bright. I'll poke them with my tweezers. Oh, I thought I threw my tweezers away. You can see these little blood vessels coming up here. Whoops, I did it again. Right over here. They're going out, picking up oxygen. They go back down, and there's actually two aortas. There's one that's called ventral, which sits up here that you just cut out, and there's one that sits right along the back wall underneath all this goo, which we're going to find next. Ready? We're going to cut this open. We're going to look at the internal organs in the abdomen. So get your scissors. And just like the dissection book shows you, we're going to cut straight down the middle. We call that a sagittal cut, if you remember. There's the dorsal aorta. So it shows blood coming out of the heart, through the gills, down to the dorsal aorta, and then that will go all the way down the body. When you cut this, you don't want to cut any internal organs. So you'll go underneath and pull up. I always pull up with the scissors when I'm dissecting so I don't cut anything I don't want to cut. I'm cutting. Whoops, little snip. That one's kind of tough. I'm going to just cut the muscle here. There we go. All right, I'm in. So I just went right below that bone. I can feel it squishy. Made a small cut. Put my scissors in. Did I cut? Whoops, I had them in. There we go. Point up on the scissors. I can actually lift the shark with the scissors because I don't want to cut deep. I want to keep it superficial, remember? So I'm going to cut, cut. You see how it slides right through? Cut, cut. So much faster when the skin wasn't there. But I'm still cutting straight down the middle, as straight as I possibly can. I'm shooting for the cloaca. Right down the middle, down the middle, down the middle. And then boom, I hit something. Didn't make it to the cloaca. I hit something right here. That, if you remember, we talked about this being a pelvic region. That is the front part of the hip. And it's a piece of cartilage. In us, it's called the pubic symphysis because it's cartilage and unique, but I don't think there's a special name in sharks because it's all cartilage all the way across. So I'm cutting past that, but I'm gonna have to get the cartilage way down here towards the beginning of the scissors and squeeze, cut. Whew, it's tough. Tough, tough. May not get through it this time. There we go, snapped it. Okay, so I snapped, I separated the hip. I'm gonna go transverse, which means across, and I'm gonna cut right above where the hip socket is, where the pelvic fin goes into the body, just like this, sliding. Cut, 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 cut. Got it. Cut. Coming back. I'll do the same thing on the other side. Flip my hand around. Cut, cut, cut. There we go. I kind of open this like a book. All the way up. I'm going to make one more cut just to make this easier. Up here at the beginning, I'm going to cut sideways, right through the muscle. That skin is really tough on my shark. But the irony is that sandpaper or shark skin could actually sharpen scissors, but it also dulls them really fast. All right. So I'm cutting just to make a book. I can open these pages like a book like this, and that's what I'm going to do. I'm going to slide my shark into the middle of my dissection tray. Make sure it's nice and open. I'm going to take 4 pins, one here, stick it down. There's 2, stick it down. Number 3, sticking down. And number 4, sticking down. Oops, someone popped out. So I'll just move it over a little bit and stick it in again. There we go. That's better. So now I can see all the internal organs. First thing I want to look at, and most of these are GI tract. First thing I want to look at are these things that look like eels to the sides. If you look at human in this picture, you can see this is our liver. It stays mostly up here towards our chest. You have 1, 2 lobes, a left and a right. Right one's a little bigger than the left. Oh, and right there at the tip of the liver, you have something called a gallbladder. So we're going to take this, which is their left liver. Feel it? Man, it's so cool to feel this. So the liver processes blood. Anything that you eat from your GI tract, once it goes into your body, the liver cleans that stuff up. So when you eat proteins and fats and carbohydrates, the liver helps clean them up. Here's your right liver, over here. If you get toxins in your body, like drugs like aspirin or Tylenol or ibuprofen or alcohol or any medicines, even though you're given the medicine to help get you better, the liver will try and get rid of it because it doesn't belong in your body. So the medicine works for a short time because it works, and then the liver cleans up the rest of it. And there's the gallbladder. Left liver, right liver, gallbladder. This is technically called the middle liver. Right? So kind of 3 lobes. This gallbladder is a little green thing, and it makes something called bile that's all nasty yellowy green. In fact, you might even see, see the greenness? Not green over here, but this bile leaks everywhere. Like after the shark dies, it seeps through all the tissues and everything. Nothing stops it. Bile loves fat. When you eat fatty foods, it takes and cleans up the fats, breaks them down into little pieces so that you can process them. You can live without a gallbladder, but you have a problem living without bile. The liver makes your bile and just stores it in a sac. There should be a cable coming off of it, a cord, see it? So there's a greenish colored cord that comes down. It's called the bile duct, because you need this stuff to go down to your intestines to process food. You don't push the food through your liver, you push it through your GI tract, your stomach, your intestines, and you try and take the important pieces out. Bile helps you take important fats out. If you don't have a gallbladder, what food do you have to control your eating of? Fat, right? So if people have their gallbladder taken out, a lot of the fat that they eat actually passes straight through them and comes out the other end the way it went in. Gross. So we're going to follow this. We're going to see, oh man, I don't know. Here's the stomach. I'm feeling to see if I have something in there. One of the times I dissected, my shark had 2 bluegill and a shrimp, an 8-inch shrimp. It was curled up in a ball, and we straightened it out, and it was like that long. It was crazy. I've seen a lot of the learners that have had weird things, and one had looked like it was giant Orbeez, just big balls. The shark ate. All right, so we're gonna follow mouth down. So you want to be able to see your mouth. I'm gonna grab the probe. I'm gonna use the dull side of the probe, the flat side of the probe. I'm gonna go in the mouth. We already saw the tongue, roof of the mouth. I'm gonna kind of wiggle a little bit, wiggle, 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 wiggle. Wiggle, 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 until I can feel it down here. So you're gonna have to feel, this is called palpating. And I can feel it. So I can feel how it goes into the mouth, goes down. When a shark opens its mouth to eat a fish, the fish goes in straight in, goes into a little tube called the esophagus that's right back behind this. We're gonna look at it because it does come a little bit out. Slides into the esophagus pushes it down to the stomach, which is all of this section. And we're gonna cut in and find. Okay, I can feel my stick in there. So the ball, yeah, a lot of mystery behind the ball. We think that it could be some of the sharks might be farmed, and those are actually food balls they throw in for the sharks to eat. We looked at sea urchins too. There are some sea urchins that their spiky surface actually will peel off. So it might be that they're digested and that's the inside of it. You can always cut them apart, the ball. Sorry, I'm talking about somebody in the chat section. Cut the ball apart and see if there's anything inside of it. But the ball would be inside the stomach, not like to the sides. If to the sides, it's something totally different. So we're gonna pinch the stomach. Remember, here's your stomach. Your esophagus is somewhere here, but we really don't know where it starts or stops until we look inside. Just pinch it, give it a cut. I'm cutting about halfway. I don't want to cut the whole thing apart. There we go. Cut halfway. Now I'm going in. Whoops. Oh, problem there. That's better. Now I can see inside. I'm going to go in, pulling up just like I did for the belly, and I'm snipping, 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 and I'm going to cut all the way down to right where it hooks. That's still part of the stomach, that J shape. So down there. I'm going to do the same thing over on this side. I'm going to cut up as far as I can underneath the liver without cutting the liver. We just pulled the liver to the side, remember? And now I'm going to open that like a book. Oh yeah, nasty. Very nasty. So this is what's left of the last meal. When you eat a piece of pizza and you think that you've chewed it all up and you're good to go for digestion, you haven't even done the beginning. When you eat something, you just break it down into parts that are safe to swallow. So you swallow them. They come through here, the esophagus. I just happened to cut. Look at that. It's like perfect. That line. See how the liner down here on the inferior part, remember this way is inferior, caudally. See how there are lines going like this? That's the stomach. These are called rugae. And when the shark's alive, or when you're alive, if you eat a big meal, like let's say the shark goes to a Chinese buffet and just stocks up on food, right? So it eats it, eats it, eats it. These rugae will flatten out until it's full. Like the shark that had the 2 fish and the shrimp in it had barely any rugae because they were all flat. It was so full. So if you have stuff inside yours, you might see less rugae, but the rugae are the long lines. On this side though, these are not rugae. See these little spiky things? They're actually like fingers coming out at you. They're called papilla. Those are the esophagus. So when you don't have these in your esophagus, actually you have hair-like little papilla in your esophagus, but nothing like this. They're microscopic. When you swallow, your food by weight just gets pushed down through your esophagus, drops in your stomach, and your stomach locks, right? So that the food doesn't come back, hopefully. When a shark swallows it, the shark's way open. It swallows, it gets in here, and the papilla kind of like are grippy so that the fish doesn't swim backwards, right? And then the shark just goes gulp, 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 gulp. The papilla help push it down, shove it into the stomach, and then lock, right? If a shark doesn't like what it ate, this is disgusting, but cool. The shark can actually take its entire stomach, push it up through the esophagus, and push its stomach out of its mouth to empty everything, and then suck it back in. It's like, ooh, that wasn't good. Bloop, and then clean slate. So when you eat and everything is down here, like that fish or pizza or whatever, it sits in your stomach for potentially 4 hours. So if you eat breakfast, and it's actually a good healthy breakfast, like oatmeal or whatever, it'll sit in there for 4 hours being smashed, and your stomach's trying to smash that oatmeal into something like baby food. So it has to become baby food like this. This is just thickened baby food. That's what it has to look like before you can actually push it into your intestines. So if you ate an egg, squishes it till it's baby food consistency. And then when it's baby food consistency, you feel this thing, it's hard. This wasn't so hard. This is hard because this is all muscle. And it's called a sphincter. A sphincter is a round muscle that squeezes on tubes. So you have a sphincter at the top of your throat so that you don't swallow air. You have one at the bottom of your throat so that whatever's in your esophagus, well, whatever's in your stomach can't go back unless you vomit. So you have a sphincter there. You have a sphincter right here so that your stomach has to grind and shred and turn everything into baby food. And then after that, the sphincter opens and pushes it in the intestines. On you, you have a small intestine, then a large intestine that has a sphincter, and then going out of the body, you have one last sphincter. So they're round muscles that make sure that the food only stays in certain places at a time. That's what that is. This one's called the pyloric sphincter. It turns into the intestine. Right? So food's in here, baby food consistency. When the shark's ready, it opens this up, pushes some of that liquidy food into the intestine. You have a small intestine. So there's your stomach. There's the pyloric sphincter right there. Pushes food into the small intestine. Small intestine takes all the good stuff out of the food. So in the pathway going all through the small intestine, you're pulling out sugars and fats and proteins. By the end, you just have a dark mush that you know what that's going to be, right? So it's going to be feces. That goes into our large intestine, and the main purpose of our large intestine is to hold that feces and move it slowly along, pulling all the water we can out of it until we use the toilet and we flush it, right? The whole purpose for the large intestine is to keep as much water as you can, because you walk on land. You need water. You have a hard time keeping water. Does a shark have a hard time keeping water? It swims in the water, right? So what organ doesn't it need? It doesn't need a large intestine. So it just has an intestine. This would be the equivalent of your small intestine. Let me slide this down just a little bit so you can see. So your small intestine actually has lots of folds inside of it, so the food has to go over the folds and it gets processed and smushed and cleaned and all that stuff, getting all the pieces out of it. This is a spiral intestine. Can you kind of see the lines? It's like a corkscrew. So if you go on a slide that's a spiral slide, that's exactly what this is like. So if we cut into it, I'm going to cut right about here. Oops. And go in just like we did before. And this might be a little more challenging because of that spiral. But I'm going to try and cut as much as I can. And it's too tough. So mine has a really tight spiral. Some of them are a little bit more loose. I'll cut closer to where you can see it visibly. Here we are. See inside there. That's not all food. There is a little bit of food-like product in there. But see this piece of tissue right here? That's part of the wall of the intestine, and it spirals around to this piece of tissue that just keeps coiling all the way down. So the food will go whoop, like one of those gumball machines that drop it. And as the food's passing through here, it's getting all the nutrients it can out. And then finally, it doesn't have to stay and get stored and pull water out. So when a fish poos or a shark poos, it just comes out as particles, just bleh. I'm going to be vivid here, and it's like diarrhea. So it doesn't get compacted or anything. It just goes through, they get all the nutrients they can, and then bloop, they just drop that into the ocean that you're going to have a beautiful vacation and swim all around for. Let's see, how do they kill the sharks for harvest? I don't know exactly. I think they do it in different ways. So some of them are caught in nets when they're doing other fishing, and others are harvested, like in ponds, kind of like Dixon's, how they grow fish right there in the pond and stuff. And I think that's why the balls are from the ones that are from a farm. And then like a bluegill. You don't see bluegills in the ocean where they would have caught this. That had to be from a farm that they fed it to them. But you would see more like ocean fish in those. All right, so that's the GI tract, the pathway. There are a couple helper organs. One, of course, is the liver with the gallbladder that releases bile. Bile comes down here, and what does it connect to? Does it connect to the stomach? Nope, it keeps coming. It connects, well, it kind of sneaks in there, but it connects right here to this intestine. Same with yours. Your gallbladder connects to your intestine so that when that baby food gets in here, you can pull out all the good fats. So when you have that greasy McDonald's cheeseburger, oh yeah, that fat's coming out. It's going to right into your body and go to your heart. This little organ, it kind of hides, it camouflages. So there's that J part of the stomach. See it? You see it kind of hiding right here? Here's the wrapper that goes around the stomach and the intestines, and it hides in that wrapper. So I'm just going to wiggle underneath. And it seems so tiny. There we go, under it. See how I'm holding it up? Right there. That organ also connects to the bile duct. That organ hides a little bit, hides by going down. See, here's some more of it down here. A little bit longer. See all that? So we have a head and a tail on it. In you, it has a head and tail. It's just more organized, but it's the pancreas. And the pancreas releases chemicals that help you digest carbohydrates, which are sugars, and proteins. So the three main things you want to get out of your food are carbs, proteins, and fats. Bile helps you process fats to get all the good stuff out, and the pancreas helps you process proteins and sugars to get all the good stuff out. When I say sugar, the pancreas might trigger a hormone in your mind. It's called insulin that helps you regulate or control blood sugar. So if someone has diabetes, it's the pancreas that is, well, not always, but typically to blame. Okay, so the pancreas. One more organ right here. This is a spleen. Before you're born, your spleen and your liver actually make all of your blood. After you're born, your spleen and your liver destroy all your blood. So when you make blood, each cell in your blood lasts for about 100, every red blood cell lasts for about 120 days, so 4 months. At the end, it's not very squishy, it's not a good cell, so your spleen pulls it out, destroys it, recycles the parts back into your system, and then makes another red blood cell. But bones will make them the next time around after you're born. So that's the spleen. One organ down here, there it is, it's the one poking right up at me. That one is called the rectal gland. The rectal gland is unique. We don't have one. So rectal glands will pull salt out of the shark's body and push it back into the ocean. Salt's actually dangerous. If you've never heard, too much salt in your body can be really bad for you. Same with a shark. You know, it's still an animal, it's alive. So all that salt goes into this gland, and that gland dumps into the cloaca. So now you have urine, salts, poo, and reproduction, all from one gland or one cloaca. All of them go out. And that's everything on the inside here, okay, as far as we consider like abdominal organs. You can see that if you pick this up, there's a wrapper. I cut mine a little bit, but this wrapper wraps all the way around and holds everything in place. You have one too. It's called the peritoneum. It comes all the way down, wraps around the inside of the belly, comes over to the side of the belly, comes back up here, and wraps back in. It's almost like a balloon that completely wraps around your GI tract to hold it in place. Like I said, every organ has its own wrapper. Even groups of organs have wrappers. Let's move this to the side. If you had a boy, there's a gland right here and a gland right there. Those are the testes. They make sperm for reproduction. If you move everything to one side, you should see a little cord. You see it? I don't know how clear you can see mine, but see how there are coils inside of it? It's like a spring in there. This is called the vas deferens. And when they're ready to reproduce, they release the sperm down the vas deferens and they dump it out in the environment, and then the female sperm catches it, or sorry, the female fish catches the sperm, and then they have babies, pups. If you have a female, you'll have something that looks a lot like this, but you'll probably have like eggs stuck all over the place. Okay? So this would be their ovary, and the little eggs are the developing pup structures. And then when they have the pup, remember, they can do 4 different things. They can drop the eggs out into the environment and hope that they're in good shape. They can grow the eggs inside of them and hatch them, or they can have a live birth like we do, where they have a structure called placenta that keeps feeding the baby pups until they're ready to be born. So what's kind of scary, and this makes me think of it, is I skipped a story in the beginning when we talked about endothermic and ectothermic. Endothermic sharks can swim in cold water. Normally, sharks don't like fresh water and cold water like rivers and streams, but the movie Jaws was based off of sharks that swam actually through New Jersey and into New York up the river and attacked people. And those sharks were called bull sharks, not great white sharks. But the bull sharks can actually swim. If you're familiar with your United States, I'm not the best artist, but here we have Florida, not perfect. There's Texas, there's California, all across the top. Very rough. But if you remember, from the Gulf of Mexico, the Mississippi River runs way up here and splits off into the Illinois. Bull sharks have been known, and these are the mean kind of aggressive sharks, because they can make their own heat. They'll swim into fresh water up the Mississippi River. They've been known to come into the Illinois River and drop their pups in the Illinois River, because now you've got these aggressive little shark pups that are eating all of the not so aggressive fish in the Illinois River, like bluegill and stuff, eating them up, and then they swim back out here to play with all the grown-up bull sharks. So female sharks can actually lay their eggs in environments that they know they're safe, like in riverbeds. And then those hatch and sharks swim. Not in Peoria. I couldn't find anything that said that we saw bull sharks in Peoria, but yeah, down at the end of the Illinois as it dumps into the Mississippi, there have been bull sharks. All right, respect for your shark. We're gonna close it up. Here's a pen, here's a pen. So we have 1, 2 pens. I just pulled 3, 4, 5. Oh, missing one. There it is. 6. 6 pins out, all accounted for at the top. Here are my scissors up at the top. Tweezers. Probe came out of the spherical. I'm pushing it into the pad. And the only thing that we didn't look at in here that's really kind of hard to see. So there's the vas deferens again, that coily thing. Here underneath it, you can see here's a vas deferens, here's a vas deferens. See that bubbles? That's the dorsal aorta. So that's where blood was coming down to the rest of the body. And you can kind of push the bubbles along. When your fish died, they cut the tail here to let the blood drain out. So you didn't see a lot of blood inside of it. If we look at the vertebra, this is kind of cool about sharks too. So if you have a good microscope and you know what you're looking for, a shark vertebra isn't exactly like ours. Ours has what we call a body, a firm part that they stack. And then we have a spinal cord. They have this body right here, but it's round like a tree, and every year it gets an extra ring. A shark never stops growing. It will grow its entire life. It never stops. But if you slice this and you look under a microscope, you could count the rings and find out how old your shark was. Kind of cool, crazy. Right above it, so if we're looking like this, and we fold, here's the dorsal side, the dark side. Here's the ventral side because it's light, right? So that's how we know this is the front of the shark. If you look at the dorsal side, that little speck, here's the body. There's a little squishy spot here. That's the spinal cord. You're welcome to cut way up higher in the body where that's bigger and you can see it better, but that's the spinal cord that controls everything, all the signals to and from the brain. On the opposite side, the ventral side down here, you actually have 2 little holes. You can probably see them. There's a big hole right here. That's an artery. There's a little hole here that's a vein. Arteries are carrying blood down to the tail. Veins are carrying the blood back up from the tail. Here you can see some muscle groups. They kind of flake. It's like on a salmon. When you eat salmon and the muscle groups flake off, or a chicken. I guess I didn't realize I was a scientist when I was young, but I loved when I ate a chicken leg, I would actually take the muscle groups and peel them off, not knowing they were groups of muscles. I would take them, peel them off. And then it's that tendon on one of the muscle groups that attaches to the foot. Ugh, gross. You never eat that because it's all chewy and nasty. But when you're eating like fish or chicken, kind of take it apart and peel it and see how things work. You can see the direction of the muscles. So these go sideways. That means that they twitch this way. These go up and down, which means they twitch backwards. Muscles always pull in the direction that they're facing. So they can only pull in one direction. You have to have hundreds and hundreds of muscles like this to get a nice smooth movement out of a tail. It's just like you in your arm. You have dozens and dozens of muscles in your arm that are controlling your hand and your wrist and your fingers. And you just think it's just moving one finger. It's amazing. And if you ever make it into one of our in-house stems, then we build a robot hand where you can see how to control every finger. You build it and take it home with you. All right, so we covered all the systems that we meant to cover. The only thing really left was nervous system part 2, which was the eyeball, and we already did it. Here's a page where you can see some of the structures and compare, see if you can identify yours on there. Rectal gland, spleen, stomach. Here's a page where you can label, right? So the green ones are pretty easy because we talked about them a bunch of times. The purple ones are a little bit harder. You may have to actually look it up to find out what the specific name for that blood vessel is, or this specific vessel going to the gills. If your book is nasty, if you just drop me an email, I'll send you a digital copy of it so you can print it. If you took any notes in it, like I have tendency to write notes, maybe your parents, or if you have a tablet, you can flip the pages and they can take a picture of the page with their notes. Right. We talked about the GI tract. We talked about the vertebra a little bit. Talked about the rings. We dissected the eye and talked about the muscles and how they work. And the only thing left was the nervous system part 2. And because of time, I will actually talk about it. It'll be recorded, and if you want to come back and do it, you can. But if you have to leave, I understand. I'm just going to show you right now how to get into the brain, right? You've done part of the search. If you want to dissect out the other eyeball, you're welcome to. But the easiest way to get to the brain is actually where you remove the eyeball, you're going to start separating skin again. So I will make a little cut so I can get under the skin. My tweezers. There they are. The skin's kind of hard, so once you get under it, it's cake. Crunch, crunch. That was skull. If you look at the picture, here's a side view, here's a top view, and here's when you cut, like a bottom view when you cut down. So we're going to look for this. We're actually looking for where the eyes would be. It's going to be thin cartilage bone. If we snip there, we can kind of peel and break. In fact, this is gross, but if you squeezed hard enough, you could crush the skull because it's cartilage, and you can kind of hear it break when I pull back like this even. So see how I separated? So I'm going to do this quickly, show you how to expose the skull, and then I'll show you how to clean up. And like I said, if you just want to roll the black mat over it, you can watch the cleanup video to see how to completely clean it up. Skin's not perfect. There we go. I'm underneath, separating, wiggle, separate. Oh, 2 hands. Skin's tight, tough today. Separating, cut, separate, cut, separate. Oh yeah, this shark is tough. Actually, cracking the skull a little bit as I do this. It's almost like cracking a walnut or cracking a lobster or crab. Same idea. So I'm pulling back. Now I can just peel the skin all the way down to the nose. You can see the cartilage in the nose, which is pretty cool. You can see the skull, that clear, jelly looking but hard stuff is skull. Peel back a little bit more. If you want, you can peel down here and you can actually see inside the nair or nostril. I'm not going to. Still going like this. Peeling, 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 peeling. And again, if you wanted to, you could feel the neck. Here's the head, here's the neck. So looking at a picture here, you put your fingers on the neck, hold the head and wiggle it. And if you wanted to, you could cut, you could cut right at the base of the skull where it goes in the neck and cut the vertebra and look at the spinal cord here. You can actually bend the head up and you see the muscles in the spinal cord. But back to the skull, right? That side. Peel open. Open. Up closer to the neck, you're gonna get more muscle. So if I pull this back, I'll start seeing the muscles. There's some muscles. And they have muscles on the top of their head too, just to steer a little bit better, to wiggle their head. Dogs and cats have muscles up here to move their ears. Kind of fun. And down here. And I'm just heading towards the other eye. But I'm not going to take the eye out. Oops. So I slipped over the eye. Separating the skin. That side too. Cut. Cut, cut, cut. The skin's like sandpaper on this guy, real bad. I'll peel back. It's not peeling very easy. Let me cut again. There it goes. And I peel a little bit of the muscle. But right through here, you can see the brain. So you can see the olfactory path will be down here going to the nares underneath. Here you can see the olfactory bulb, which sits right there, around the spot. Here, you can see the cerebrum, which is the part that's most like human for our oops, sorry. Didn't realize that. That's a little bit better. So here you go. Olfactory tract going down to the nose, which comes down here, comes up to the olfactory bulbs, which are right under here. Here's the cerebrum, number 4. So it's just slightly higher. And that's more like us. So it's the complex thinking. Hunter fish have a bigger cerebrum. Bottom feeders, smaller. Here's the cerebellum. So this is for balance and coordination. For us, it's for walking and tumbling and stuff. For sharks, it's for skilled swimming. And down here's the brain stem. which controls all your basic life functions like coughing, sneezing, heart rate, breathing, choking, gagging, vomiting, all those different things. So if something happened to this, instantly, if your whole body were perfect, but something happened to that, you wouldn't be able to sustain life. It would be fatal. Up here, number 4, if something happened to that, it would change your personality, but you'd still be alive. The cerebellum right here, if something happened to that, you wouldn't be able to walk or maintain balance. So let's go ahead and cut. And again, you can hear it tap, but it's actually pretty fragile. So I can cut anywhere I want. I'm cutting right here, right above the eye. Oops. I'm trying not to cut too deep because I'll definitely, and I did it. So I cut a little bit and then my scissors poked in, which means I just cut the brain. So now that it's cut open, I'll just tilt it. There we go. There you can see the brain on the inside. See the pathway if I just keep tilting. So I went in between the eyeballs and I made a couple cuts. I accidentally stabbed too hard here instead of cutting. But I can peel. Oh, it ripped. Nuts. So the part that we're looking at right now is, oh, yep, they stayed in there. Oh, bummer. Anyway, so these little bulbs stayed right there. You can kind of poke them, the olfactory bulbs. Huge. When you look at the size of the brain and the size of those, that means their sense of smell is very well developed. They have to have a lot of brain tissue for it. Here's a cerebrum, which would be like your brain, not too big, like the top of your brain where you think and process information. Back here, going back, it's our cerebellum. So let's see if we can cut that a little bit. Not cerebellum, but the bone above it. Just gonna snip, trying to stay up. And the brain is super soft, and it's like that in life too, very soft. If you took a block of cream cheese and let it sit on the counter for a day or so until it's nice and warm and stuck it in your hand, that's still thicker than your brain, but that cream cheese would kind of shape around your fingers and you flip it over and you'd see finger shapes. That's the way the brain is. This has been preserved, so it's a little bit more firm, but the brain is super mushy. I'm kind of cracking it and pulling it apart like like I'm eating crab, I guess. There we go. I'm gonna try and split it down the middle without destroying the brain. There we go. So I smashed it a little bit, but there's cerebrum, there's cerebellum right there, and you see the top of it just kind of got a little bit smashed. Keep going, or you can keep going, I guess time-wise. You can go above it and cut, and if you just keep, squirt, that's why we're goggles. If you keep going and cut down, you'll find the brain stem that matches up to that, and eventually it'll turn into the spinal cord. So once you get down, here's the skull, once you get into the neck, you notice no more brain stem, it's actually spinal cord. Anyway, so you could cut that and cut it apart. But that's all I can cover with you right now. You can take your time dissecting stuff. I'm going to show you how to clean up. First thing I'm going to do is make sure my sharps are all in place. I'm going to roll this over and put the heart back in the chest. That's how I am. There we go. Respectful. Appreciative. I'm going to put the lens back in the eye. Eye back in its spot. Okay, 1, 2, 3, 4, 5, 6 pens safely stored. I'm going to take the probe and go sideways in. I take my scissors, push them under, and again, if you keep them closed, that's fine. If you want to open them up and tuck them into this, you can do that too. I'm just tucking them in. Tweezers are in there. Ruler's there. I don't want my pen anymore. I don't think you would want it either. I had extra gloves. You won't have gloves going in here. It should be everything going in for now, just for now. It's off. Yeah. So you've got your black mat all the way around, right? Rolling it back, you can see my black mat. I'm going to take one glove off, but not until I know which side I'm looking for. I'm looking for the garbage bag that had the seam. Here's the seam. That's the glove I'm leaving on. So my seam is over here. That's the bottom of the trash bag. I'm going to go the other way, that way, double check. Perfect, no seam. So this is the glove I'm taking off. To get it off, I'm going to pinch and roll. So if that's stuck down to my wrist, I'll grab here, which is trickier. Ah, so oily. There we go. So I'm underneath it and roll. Pulling my hand out. My hand is sweaty, but clean. A little sweaty. So now I'm going to open up the bag with a clean hand. No gunk on this, no gunk on that. There we go. I'm inside the bag with my clean hand. So now I'll grab the dirty side, roll my hand down here. I'm going to change cameras real quick so I can show you this. A little back. There we go. That's Taylor. That's Taylor. So this was the clean side, remember. I feel like the camera switched perspectives, but this is my clean hand, my dirty hand. I'm going under the fish, under the pad, way down there. I'm all good. Yep. And just rolling it over. So I loosen up the bag underneath. Now I can push everything in the bag. This way. Rolling around this way. And my dirty hand's still sliding the fish in the bag. Okay. So now I'm far enough. I actually have the bag under here, all the way to the fish is that way, towards the bottom. I'm gonna take my thumb, go under, pull it up. My goggles in. I don't have an apron, but I would take my apron off and put it in. And now they're all in the bag. Here's the top of the bag, everything's inside. Cleaned up. Finished. Go wash your hands, eat your lunch, do whatever you're gonna do. Thanks for playing with us. Thanks for participating. If you have anything that's cool that you found while you were dissecting the shark after we left this, just drop us an email. There's also a bookmark that came with your stuff. You can use it as a bookmark, or you can check out the bottom. There's an app that you can download pages out of a coloring book that are pretty cool. So you can download things like picture of a heart. You can color the heart, download the app, and then you can look at the heart through your tablet or computer or whatever the app's on, and it pops out in 3 dimensions with your coloring on it. There are games where you're a white blood cell attacking bacteria, videos of like circulation, a maze that you can do in 3D. There's lots of cool stuff. You can do the same thing with a skull. And this is one of the fun things that are on there. There are also other STEM events that we do. Like we do another dissection with this, except we use a sheep heart. So it's a big heart that's connected to the lungs. So we can look at airway, pathway. We just dissect the sheep eyeball that's a lot bigger. We look at a bone and a kidney, all from a sheep. So that's the other big dissection one. Thanks again for playing. It's been fun. It's good to see a lot of you that we've seen a bunch of other times in the past. And have a good day. Hopefully talk to you soon.